leadership with people like Dr. Vora, Harshit Merchant, a few other senior members to basically bring in a concept which could get students to understand their engineering subject much better in a practical manner. And that is what the concept when it all started in a meeting at Delhi in 2006, culminating to what we have today, a wonderful 19-year of growth story. We started off first in 2006 with just one category of hBAJA, which is hBAJA, the IC engine, powered by the engines which were provided initially from Briggs and Stratton. Today we have the Honda engines driving the hBAJA vehicles. Then we moved on to the hBAJA under the guidance of late President Mr. APJ Abdul Kalam. He was the one who guided us to start this event, which was successfully started in 2015. Then we moved on to the hBAJA in 2024, where we started off with 2% of hydrogen, which subsequently in 2025, we increased it to 18% of hydrogen. And we plan in the next chapter, hydrogen close to 30%. We also started the hBAJA in 2024, wherein we could give students the challenge to make their own autonomous hBAJA, which is the talk of the town today in terms of all the ADAS levels and all the automation that is going into every vehicle model that you see on the road. So with these four categories, our journey has been incredible. It has not only brought students together, it's brought all of us together. It has brought the industry together. It's brought the ministry blessing us in every manner, seeing what we are ultimately providing in terms of skill development to this country growth. Next slide. Ashish, the next slide, if you don't mind.
Yes, sir. Dash.
Sorry. So this was the road journey. We began in 2006, as I told you, sometime in September, where we had the first meeting to conceptualize this program. And then we started the first run of the IC engine hBAJA at Matrax Pithampur in 2007. In 2010, we introduced the hBAJA aptitude test, a standardized test for recruitment through the HR meet that we organize every year for all the hBAJA participants. Then in 2015, we launched the E category of the event under the leadership of late Dr. APJ Abdul Kalam, as what I mentioned earlier. It was his vision that translated to this reality. 2018, we expanded to 2 locations because the event was growing and we couldn't accommodate all the students in Matrax. So we had to expand this to the second location, which was IIT Ropar in the north. Then in 2021, we had to have the virtual hBAJA rounds, which was the introduction to the virtual dynamic events with the IPG car maker. In fact, even during COVID, when everything came to a standstill, our events continued on a virtual manner. And that is what is the IPG car maker that helped us doing it. In 2024, we had the first hBAJA event at Pithampur. Again, a big milestone for students wanting to focus on the hydrogen engine. In 2023, we had both the hBAJA and hBAJA category launched. That's what I told you before 24. And in 2025, the first ever hCNG buggy was 25. The first ever hCNG buggy was flagged off by Sri Nitin Gadkari at Pithampur. It was again a very great honor for us that Sri Nitin Gadkari could come and flag off the first ever hBAJA buggy. It was also the culmination of 10 years of hBAJA in 2025. In 2026, we increased the hydrogen percentage in the fuel to 18%. And the event was very successful that we conducted at Matrax. And that's what the entire roadmap of BAHA has been beginning from 2006 to 2026. We have very ambitious plans for the 2027 season, marking our 20th year of uh, beginning. We have various programs that we're going to be launching very shortly. You'll all be privy to whatever is going to be added in 2022, specifically to mark the 20th year of BAHA's existence. So that's all about the journey. I would now request Dr. Vora to take over and continue the presentation. Dr. Vora, incidentally, is a senior advisor. He was the first member who started off this event along with Dr. Goenka. The brain behind BAHA is actually Dr. Vora, Dr. Goenka, Dr. Harshit Merchant, and a few others. I would request Dr. Vora to continue this presentation and give his thoughts and direction to all of you all present here. Thank you so much.
Thank you. I must say, it's been 20 years working on BAHA, and every year we had new members coming in and supporting us, and then staying with us. Like Balraj is one such member who was earlier a sponsor on behalf of BPCL, and now he's become a part of the family and now the chair of the organizing committee. BAHA in this 20 years have a lot of accolades, which Balraj already explained how we moved forward, and every year we used to do something new, whether it is something new we do in eBAHA or in hBAHA and so on. Today we will concentrate in hBAHA. Next slide, please. Yeah. So this idea of hydrogen BAHA came in when in January 2023, our Indian government released Green Hydrogen Mobility Mission Plan. In this plan, the government said that we are using petrol, diesel, these are all derived from crude petroleum, and that we are buying from abroad. You all know that during Iran war, we had a lot of tension, then what will happen to the crude petroleum which is coming in from Iran. So then we got it from Russia and so on. And the worldwide, the prices of petrol and diesel had increased. Our government did not increase that price for few months, and we managed without that. That is how we were able to strategize and ensure that. But this cannot continue for a long time. So that is sure that the fuel prices are going to go up, whether it is gasoline or whether it is diesel. Today it's more than 100 rupees per liter, and hence we need to find out alternate source. And many alternate source research has been done, whether it is CNG, whether it is LPG, biodiesel. So all those options have been tried. LPG and CNG, we can use it 100%, and it is good because it reduces hydrocarbon and carbon monoxide drastically. However, fuel like ethanol, methanol, that is the talk of the town this day. I'm not going to comment on this, but it's worth researching. A lot of research is being done and the experiments are continuing. CNG has been one good fuel, which is not coming from crude petroleum. So I must tell you, when you refine the crude petroleum, which we import, most of our 90% of the crude petroleum is imported. And this crude petroleum has to undergo a refining process called distillation. And under that refining process, what we get out is gasoline, diesel, kerosene, and also LPG. LPG is the first thing to come out. But CNG is not coming from this crude petroleum. It is coming from the earth crust. So CNG is a fuel which is abundantly available in India. And hence we thought we must start using this. So that's how in 2024 we did this competition with 100% CNG, and but with an aim that we must use hydrogen in fuel, and hence the event was called as hBAJA and not cBAJA, that is CNG BAJA. In that first year in 2024, we did 100% CNG to understand that we are confident of conducting such event with pure CNG so that next year we can add hydrogen. Then in 2025, as Balraj said, with the blessing of Sri Nitin Gadkari, we started with 5% hydrogen in CNG. So with hydrogen in CNG, it is a pre-mix blend. That is, you take CNG, you take hydrogen in the ratio of 5:95, mix them together, put them in the cylinder, and then entire cylinder, set of cylinder, which we call it as cascade, will come to the competition site, and the team would fill up that hCNG with 5% hydrogen in CNG. So that's what we did, and Volvo iShare was kind enough to support us to get that hCNG. And it was a wonderful event, 2025, a beginning of a new era where we talk about hydrogen. So why hydrogen? Because hydrogen is just hydrogen, there is no carbon in it, and hence there won't be any formation of carbon dioxide and also carbon monoxide when you burn hydrogen in the combustion chamber of the engine. Moreover, we have millions of vehicles running on road. As an approximate, I will say we have 400 million IC engine vehicles running on Indian roads from last so many years, whether they are BS1, BS2, BS3, BS4 or BS6. All of them are running because in India, the life of a vehicle is higher than the life of a human being. And दादा भी use करेंगे, बाप भी use करेगा, पोता भी use करेगा. It will continue. That is how we have been used to working. Now that scrapping of vehicle has come, and it is understood that old vehicles like BS1, BS2 are emitting very high emission. So we have scrapping policy for commercial vehicle, that is auto rickshaws, buses, but we don't have any scrapping policy for domestic vehicle which you and me own or our parents own. But that will also eventually come, and there will be subsidy if you recycle your car and buy a new car and so on. Even today, there is a subsidy if you diesel or petrol and buy an electric bus. So the era of electric vehicle came in because that was an immediate solution. And yes, electric vehicle also do not give any emission, no CO, no HC, no NOx, because it is just electricity. But somewhere where electricity is produced, like we burn coal to produce electricity, then there will be carbon dioxide formed there, right? So it is an indirect way of producing carbon dioxide, even though the vehicle will not produce carbon. So it will not carry forward to the cities where electric vehicles are used. And in India, 40% of our population are staying in big cities or metropolitan. I would say maximum 50 cities, big cities, if you collect, then 40% of our population is there. And to save this 40% of our population, yes, electric vehicle, even if we use burn coal and generate electricity somewhere else, will be a good solution, a temporary solution. Now, with this electricity, we are able to run electric vehicles, but we will not be able to run 100% penetration of electric vehicles in India because we are producing more than 5 lakh passenger vehicles and around 5 million passenger vehicles and around 23 million 2 and 3 wheelers. I will say 23 million 2-wheeler, 5 million passenger vehicles, 1 million 3-wheelers and 1 million trucks and buses. So total it comes to around 30 million vehicles which we are producing. All of this cannot be converted into electricity. We require a huge electricity. And then we will have problem also using electricity in our home and in villages. So we have to be careful. So India is a land of diversity. So all these fuels, whether it is gasoline, whether it is diesel, whether it is CNG, hCNG, hydrogen, EV, hybrid, everything is going to coexist yeah, there would be a lot of experiments with our vehicles also. But if you want to really reduce carbon dioxide and reduce global warming, we'll have to do all these things. We'll have to face it. So, why are we doing all these things? Because you must have experienced that from last 2 years, summer has been very hot. We have reached temperature up to 45 degrees in many cities and even 50 in some select cities. And hence, if we don't do this, if we don't use electric vehicle, if we don't use CNG vehicle, if we don't use hCNG and hydrogen vehicle in future, then the temperature will go above 50 degrees Celsius, specifically where the countries which are near the equator, and it will be very, very tough to be there. Right? I think I'm not going to talk more about this. We will continue with the presentation, but I just wanted to give the justification of use of hydrogen in future. So let's see that we made this event called hBAJA, which is similar to mBAJA. That is, mBAJA also uses an IC engine. hBAJA also is using an IC engine. But in mBAJA, we are using gasoline, which produces emission. hBAJA, gradually we will increase the hydrogen content and which will gradually reduce the emission. And that's what we want to say, that BAJA is also working towards zero carbon emission. Our Prime Minister has declared that by 2047, that is next 20 years, we will be using crude petroleum, we'll be importing crude petroleum, and from 2047, we will stop importing crude petroleum, we'll stop importing any form of energy. All those energy, whether in the form of electricity or whether in the form of fuel, has to be produced within the country. So we will become Atmanirbhar. And to do that, we have to work towards sustainable energy. That means we will have to use solar energy, wind energy, hydel energy, and nuclear energy. And I'm very happy to tell you that by the time I'm talking to you, 50% capacity is available now through solar, wind, hydel, and nuclear energy to generate electricity. So we just have another 50% where we generate electricity through coal burning. We have increased from 10% to 50% in just few years. And there are a lot of declaration about use of new nuclear energy. Nuclear plants are coming up, and more solar and wind energy farms are also coming up. Especially in Gujarat and Rajasthan, this has come up. And even airports like Cochin Airport in Kerala is 100% running on solar energy, and so on. So moving towards more and more % of hydrogen. But why are we not jumping directly to 100% hydrogen? Maybe one question. Our country is still not ready. We need to produce green hydrogen. When I say green hydrogen, hydrogen using sustainable energy and not burning coal. And yes, in Gujarat, again, more and more green hydrogen production has started. One is coming up in Kutch district of Gujarat, and one is coming up in Jamnagar in Gujarat, where hydrogen will be produced using sustainable energy. The green hydrogen will be produced. So we are all moving towards it. The event would be similar to mBAJA, where we have a virtual round, we have a static and physical dynamic rounds. Everything same as mBAJA, only the engine is different. Instead of a gasoline engine, we are very lucky to have Honda as a gasoline engine. And also we are very lucky to have Greaves to give us a CNG engine, which is now converted into an hCNG. Greaves have done extensive research, and there will be a presentation from Greaves on what they have done and what type of engine we have to use and how we have to take care of. Let's go to the next slide. So that is the vision, how hydrogen came in and hBAJA started. So this is hBAJA 2025, where Sri Nitin Gadkari ji came to inaugurate with 5% hydrogen in CNG in January 2025. Next slide. Then in 2026, the Education Minister of Madhya Pradesh came in to inaugurate hCNG with 18% hydrogen, again with the help of Volvo Asia, who helped us to get the fuel. So if you look at the statistics, we started with just 3 teams in 2024 with 100% CNG, and then 18 teams came up in 2025 with 5% CNG, and then 23 teams in 2026 with 18% CNG, 18% hydrogen in CNG. 2027, we wish to use 30% hydrogen in CNG. That is our wish, and I hope that we will succeed in doing this. If not, we will continue with 18% hydrogen. Now, why are we saying 18 versus 30, and why we are not confident? Because if we use 30% hydrogen in CNG, we will have to use a separate cylinder, where my colleague Dr. Rajib Babu will talk about that tomorrow, why we require a different type of cylinder when the hydrogen content increases. But up to 18% hydrogen, extensive research and experiment has been done in ARAI, which mentions that up to 18% hydrogen CNG, you can continue with type 1 cylinder, that is the steel cylinder, which is used in CNG and LPG application even today. So that's the limit of 18%. If we want to go above 18%, then we'll have to develop a type 4 cylinder, which is a non-metallic cylinder, and which is totally composite cylinder. We will talk about that tomorrow. So very happy to say that this year in 2027, BAHA, which will be in the first quarter of 2027, the dates are yet to be declared. 26 teams have registered, and I'm sure out of these 125 people who are here, all 26 teams are represented in this event. Yes, when we use CNG or hCNG vehicle, weight would slightly increase. The engine is slightly heavier than the Honda engine. So the average weight of hCNG buggy would be around 300 kg. Or try to design a vehicle, hBAJA buggy, which is with engine, which is less than 300 kg. Keep that as a target. And if you are aspiring to be in the top 3, then the minimum was 268 kg. So that must be your target. Actually, your target should be 250 kg if you want to be a winning team in hBAJA 2027. But up to 300 is fine. But there may be some team with 350 kg also. Doesn't matter. Weight is not the criteria. But if weight is lower, then you will have more chance to complete number of laps in the 4-hour endurance. So up till now, I think we started with 1 hour, then 2 hours. This year, we aspire to make it 4 hours. That means in 2027, hBAJA, we hope, we wish that we will be able to run for 4 hours. So irrespective of the number of laps, we have been running around 40 kilometers. In 40 kilometers with the cylinder which we are using, we have to refuel once. That means after completion of 20 kilometers, approximately refuel with hCNG, which is available at the site. hCNG is not available anywhere else in India on commercial basis. Yes, for some time it was available in Delhi and Noida when Indian Oil Corporation started selling hCNG with 18% hydrogen, but then they stopped. There is a possibility that it will restart. And so in a 40-kilometer endurance race of 2 hours, we have to refuel once. And if we do it for an 80-kilometer endurance race of 4 hours, then we may have to refuel thrice. We are working on it, and whether it will be 18% or 30% of hydrogen, we will let you know. I must also tell you the team must not do any experiment with hCNG. You must not try to get hCNG from somewhere, or you must not blend hydrogen in CNG and do all that experiment at your college, wherever you are doing those experiments. Please don't do this. Only we can do this experiment at Greaves in Aurangabad, their R&D center, or we will do it wherever the site is there. We will bring that hCNG and give it to you at that time. Till then, you can continue with gasoline or even with CNG. CNG is evidently available in many places. So if your city has CNG, please use CNG. From this year, we'll allow you to use CNG. Otherwise, gasoline is also fine. CNG, gasoline, and hCNG are like brothers and sisters. We can use one and manage with all your validation. Okay, fine. Let's go ahead. And then acceleration. So we were able to have a good acceleration here of around 7.5 seconds. Now let's go ahead, and we are at the end of the inauguration. Yeah, let's end. Yeah, I must also thank Greaves for giving us the engine, and then two more companies, that is Atul Auto and Advantex. Advantex have given us the fuel injection system, which can be used for CNG and hCNG. In future, they will make fuel injection system for hydrogen also. And similarly, we have Atul Auto, who has helped us to do the entire vehicle integration, that is integration of engine on the. We use their cooling system, engine cooling system, and the exhaust system and the intake system. And they are helping the teams to do the entire vehicle integration. It won't be same as intake and exhaust system of hBAJA. Intake of exhaust system, intake, exhaust, and cooling system of hBAJA. It will be the altogether a new intake, exhaust, and the cooling system, which Atul Auto is already using on their vehicle. We are readily using this. Yes, a lot of innovation is required in this area, which we will have to work in future. Yes, there is an innovation event also where we can do innovation, but you have to be careful. You must not take very heavy risk in doing that innovation. And we have reached that stage that we are also funding your innovation if it is good, if it is selected, and we give you funding for the proof of concept, which we did last year. Let us see what we will do this year, depending on the sponsor. Let's go to the next slide. So here we are, and in this inauguration, we are declaring that we have a 2-day workshop, and these are the various speakers from Dr. Kalimuddin, from Green. Then we have Mr. Rajiv Gaiki from Advantex. Then we have Mr. Siraj Sheikh from again Greaves, and Dr. Yogesh Agav from Kirloskar, Pune, who is known to be an expert in hydrogen, who is also working on hydrogen gensets and hydrogen trucks and buses. Then we have Makaran Lad, who was earlier in Volvo, and now he's still associated with us as an expert in hCNG and hydrogen. Mr. Piyush Balia from Atul Auto, Dr. Ajit Babu from Good Life Mobility, who is going to provide us hCNG cylinder, that is hydrogen cylinder. Suresh Sajjan, Pranjal Rathod, one of our alumni of hBAJA. And we have also volunteers like Kameshwar Yadav and VK Sandeep, also alumni of hBAJA, to take this forward. So with this?
Yes, sir.
Yes, sir.
Okay, fine. So what is the time? Kashish, can you give me the time target till what time I can speak?
Sir, 11:15.
11:15. Okay, so I have half an hour, right?
Yes, sir.
Okay, fine. So I have around 30 slides, so maybe 1 minute per slide. So today I'm going to talk about hBAJA SAEINDIA 2027, the introductory talk. Half of that is already done. I would like to show you some history. Am I audible and am I visible? Kashish?
Yes,
sir.
yes, sir. Yes, sir.
And you are able to see the full slide, right?
Yes, sir.
Yes, sir.
Okay, fine. So India started working on CA somewhere in the year 2001. Extensive research was done by various organizations like Petroleum Industry, Indian Oil Corporation, Bharat Petroleum, Hindustan Petroleum, and major experimentation were done at AREI to ensure that CNG comes to India. And for this, ARI also received an award from SAE International for introduction of CNG in Delhi. So we first started with Delhi, and in April 2001, we were able to introduce CNG in Delhi in the same petrol pump where petrol and diesel are sold. Yes, it requires a different dispensing station, but that's how it started with 100% CNG. So initial days, even today, a CNG vehicle will have a 3 liter or a 5 liter petrol tank. So in case your CNG is exhausted or it is full, you have used 100% from the CNG steel tank, then you can run your vehicle with gasoline also. And that is the reason why when you use CNG instead of gasoline, your power reduces by around 10 to 20%. Yes, emission will reduce, your fuel economy will improve, but power and the acceleration will reduce by around 10%. And hence, many people thought that we can increase the compression ratio by 1 or 2 so that we regain the same power for the same vehicle. But the problem is when you increase the compression ratio and utilize 100% of CNG, but when CNG is exhausted and you want to use gasoline, then there is a possibility that the engine may knock or detonate. There may be a detonation or a knocking in the engine because there is a limit up to which the compression ratio can be increased in gasoline. But yes, if you are using CNG and if you are using high octane gasoline, when CNG is not available, then there is no problem. So now around 2%, around 1 or 2 compression ratio has been increased in dedicated CNG vehicles worldwide or in India also. And in case you are exhausted with CNG, please ensure that we have to use a high octane gasoline, preferably. Okay. So CNG those days was called a green fuel. Now hydrogen has become a green fuel. And it does not have lead because in earlier days, CNG gasoline had lead to improve its octane number. And we can use higher compression ratio and better power and acceleration. But lead is also poisonous to converter, and it is also poisonous to human beings. So we were able to abolish 100% lead in the fuel. Another poison for us, that is human being, and also to the engine, that is after treatment device, is sulfur and phosphorus. Phosphorus in the oil and lubricating oil and sulfur in the fuel. So that also was reduced from 5,000 ppm to 10 ppm. So today we are using fuel, especially the diesel and gasoline with less than 10% sulfur in the fuel. So because of abolishment of lead and drastic reduction of sulfur in the fuel and reduction of phosphorus in the oil, overall emission come down, whether it is CNG, gasoline or diesel. And because of strict emission norms and use of after treatment devices which was there in gasoline, benzene is still there in gasoline at a lower percentage, but it is not there in CNG. We are able to have a higher life of the engine. CNG is less likely to auto-ignite on hot surface since it has a high auto-ignition temperature and a narrow range of flammability. That means CNG is much safer than gasoline and hydrogen. So in clean and hydrogen. So it means that CNG concentration in air is below 5% or above, it will not burn. So even if the CNG leaks, the chances of flammability is very, because CNG will disperse immediately. The high ignition temperature and limited flammability range makes accidental ignition or combustion very unlikely. Yes, but when we introduced CNG in Delhi, there were a lot of fire cases. I'm talking about somewhere in 2000, the year 2000 and 2001. And we used to rush to Delhi to find out what is the solution, but we found out it was there were not proper fitment and not proper usage. Later on, a lot of training were given to the drivers and the users of what care has to be taken and what precautions has to be taken, and not to use any spurious duplicate parts in the CNG line. And then the fires have almost gone. Similar to what we did with EV when we introduced EV in India, there were some fire cases with two-wheeler and four-wheeler. It happens in any technology, but eventually we have sorted out, and now no more fire cases are happening as far as I understand in EV also. Same thing will happen when we start using hCNG and hydrogen. We will be able to succeed. Okay. Going to the next slide. So CNG is a safe fuel and it can be used in conjunction with gasoline or petrol. And also the oil which we use, lubricating oil, will also have more life. So in case of a gasoline, if we are changing lubricating oil, change. These are the old figures. CNG around 80 per kg, diesel is 93 per kg, gasoline is around 106 rupees per liter. So CNG is sold in kg and diesel and gasoline are sold in liters. Hydrogen also will be sold in kg and hCNG also will be sold in kg. Today, I must tell you the cost of hCNG would be around 100 rupees per kg, which is slightly lower than, which is equivalent to that of gasoline and diesel. In case government decide to sell hCNG at the same petrol pump where CNG is sold with 18% hydrogen. But in case we decide to use 100% hydrogen at the gas station, then the cost today is 300 rupees per kg, which is prohibitive for us to shift to hydrogen immediately. That means we need to produce hydrogen on a mass scale and using sustainable energy like solar energy and wind energy. Only then the cost of hydrogen will come down, and that may come down from 300 rupees per kg to 200 rupees per kg with mass production and sustainable usage of production of hydrogen, green hydrogen. Further, we need to reduce it by another 100 kg. So a lot of research is being done where we will be able to reduce the cost of hydrogen from 200 rupees to 100 rupees. And probably by that time, the cost of petrol and diesel would go up to 125 rupees or 150 rupees per liter. And hence, we will wait for this cost difference between hydrogen and gasoline and petrol to diesel and petrol to reduce. The gap will reduce. And probably like EV, there would be some subsidy to make it easier and cost effective to use hydrogen in vehicles. Hydrogen is also required in different applications in industry. So it's not just for automotive application. Hydrogen is atomic number is 1. It is the lightest element in nature and it is renewable. But one thing about hydrogen is since it is very light and the atom is the smallest, it can get into the metal. So if you store hydrogen in a metallic cylinder, it can lead to impregnation of the metallic cylinder. It will create small pits on the surface of the internal surface of the hydrogen on the steel cylinder which we use to store hydrogen. And hence up to 18% hydrogen CNG is fine. Above that, we need to use a non-metallic cylinder. That means we have to use HDPE or a plastic inside, which gives the shape to the cylinder, and carbon fiber winding outside, which gives the strength, the strength to the cylinder, basically the burst strength. It must not burst. If you use only plastic, it will burst. So hydrogen is a clean fuel and it has the highest energy content compared to CNG, gasoline and diesel. Hydrogen can be used for power generation and also as a fuel in automobile. Hydrogen has been used in fuel in spacecraft. It is possible to use hydrogen directly in IC engine, or it can be mixed with diesel or CNG, not with gasoline. And also it can be used in fuel cells. So if we use hydrogen in IC engine, CO and HC, carbon monoxide and hydrocarbon, will not be formed. But if the temperature of the combustion of burning hydrogen in the combustion chamber is high, there would be some formation of NOx emission, right? If you don't want to have that NOx emission also, then we have to use fuel cell instead of IC engine. But today, since we have, as I told you, 400 million of vehicles running on Indian road, we must use hCNG or hydrogen in engine. But eventually, we have to shift to fuel cell. And our Prime Minister has declared that by 2070, we will be net zero. That means there won't be any production of carbon dioxide in the country. we will be net zero. Somewhere we may produce, somewhere we may reduce, but overall production of carbon dioxide should be net, should be zero. And that is possible if we shift to 100% fuel cells. Fuel cells are costly, a lot of research is being done. So we have to do this transition from CNG to hCNG with more and more higher percent of hydrogen, and then 100% hydrogen, and then use of hydrogen instead of engine in fuel cell. This is what is the roadmap. I will show you that roadmap. So when burned, hydrogen produces water and NOx as byproduct, and it is therefore not only an efficient energy carrier, but a clean and environmental friendly fuel as well. Hydrogen can substitute fossil fuel like gasoline and diesel, and therefore reduce our dependence on import of crude petroleum. So hydrogen is to be used under Ministry of New and Renewable Energy. So gasoline and diesel comes under Ministry of Petroleum, but hydrogen and other renewable energy will come under MNRE, Ministry of New and Renewable Energy, Government of India, and it is the nodal agency to drive the hydrogen program in India. You will be surprised to know that in 2005, a committee was set up by MNRE under the chairmanship of Ratan Tata on use of hydrogen in automotive application. That by 2020. So that was the target, and that's how the committee was formed. However, we were not able to have infrastructure of producing hydrogen at that time. We did not have industrialists who were ready to take risk in production of hydrogen. Now we have many industrialists who have taken risk and gone forward for production of green hydrogen in India. Subsequently, in 2013, one more committee was formed by under the chairmanship of Dr. Kasturi Rangan, and they had 5 subcommittee to provide updates on different aspects of hydrogen program in India and revamping the entire hydrogen roadmap. So one in 2005, another is 2013, and now the third one in 2023, when India, with the help of Niti Aayog and MNRE, came up with the green hydrogen National Green Hydrogen Mission Plan, January 2023. You can just Google and you can download this National Green Hydrogen Mobility Mission Plan, and maybe you can become a startup in that area. You can work in many aspects of hydrogen. So as I told you, I will repeat, India has a deep commitment to aspirational climate goal, and this is widely acknowledged worldwide. Our Prime Minister, Sri Narendra Modi, is a torchbearer for the climate goals. And as India has set its sights on becoming energy independent by 2047 and achieving net zero by 2070, we can understand the critical role of green hydrogen in India. Besides use of electric and hybrid vehicles, India, with its vast renewable energy resource, and also as an opportunity to produce green hydrogen, not only for the India, also for the world, right? And that's what we are doing it in Gujarat. So in January 2023, MNRE, with the help of Niti Aayog, released the National Green Hydrogen Mission Plan. And this National Green Hydrogen Mission Plan aimed to provide a comprehensive action plan for establishing a green hydrogen ecosystem and catalyzing a systemic response to the opportunity and challenges of this sunrise sector. So this is a deep tech sunrise sector. The objective of the mission is to make India the global hub for production, usage, and export of green hydrogen and its derivatives. So we started working on hBAJA based on this document. We got the idea based on this. So what is this green mobility mission talks about? If you download this document, the summary is that we will have to increase the demand creation of, that means we need many people who must produce green hydrogen. Industry must come forward. This will reduce the greenhouse gases, and our temperature in the summer will go below 40 degrees, which are now 45 to 50 degrees. And for this, we need various enablers, we need resources, we need finance, we need support, we need R&D, we need ease of doing business, we need a lot of startups, we need series of regulation and standard to make usage of hydrogen safe. BIS, Bureau of Indian Standard, and ARAI through AIS, Automotive Indian Standard Committee, are working on various standards related to usage of hydrogen in automobile, including the type of cylinder, the type of fuel injection system, and the type of engine and the fuel. We also need to have support for infrastructure and supply chain. So hydrogen must be produced, it must be transported to the gas station, and whether it is blended with CNG or not blended, how to supply hydrogen in the car, all those things need to work on. The most important which BAHA is doing is the skill development in the public government. So we have been doing a lot of skill development in IC engine and automobile, and then we started doing hBAJA and did a lot of skill development in electric mobility. Today, our alumni of BAHA who have participated in BAHA earlier are working in companies like Mahindra Electric, Switch Mobility, Electra in Hyderabad, and also in Tesla in USA, and many countries worldwide where EV are used. Our students who have participated in hBAJA are getting first preference in many places. Now the next we are working on hBAJA, and I'm sure when hydrogen and hCNG flourishes in India and worldwide, then our students would be working in those areas also. So students, if you're working in hBAJA, don't stop there. You can do a postgraduate program in hydrogen mobility, which will come eventually in 1 or 2 years, and then you can also do PhD in this area. So what is the expected outcome of the National Green Hydrogen Mission outcome? We will be able to produce 5 million metric ton per annum by 2030. And when I'm telling you this target, I'm very happy to announce that it has now not, even though the target is 5 million metric ton per annum, we have now capacity for 10 million metric ton per annum to produce hydrogen by 2030. So even though target is 5, we have a capacity which will double up to 10 by 2030. So that's a very good news, which will give a renewable energy capacity additional 125 gigawatts. Yes, there will be an investment of more than 8 lakh crores of rupees, and we will be able to create more than 6 lakhs full-time jobs by 2030, right? And we will be able to reduce 50 million metric ton of carbon dioxide emission if we use hydrogen or hCNG in vehicles and other applications, right? So this is how the green revolution is moving forward. So we require a lot of people who will work in usage of generation of electricity, sustainable electricity, windmills, or solar panels are used. In future, every building will have a solar panel, every parking will have a solar panel, and every industry will have a solar panel, and every airport will have a solar panel. The second area is where we need to generate hydrogen. There are many ways to generate hydrogen. One such simple and proved method is electrolysis of water and dissociate water into hydrogen and oxygen, and use this oxygen and hydrogen for useful work. This hydrogen needs to be stored in a storage tank, preferably not steel tank, but composite type 4 cylinders. So we will have to produce big cylinders, whether it is for storage or whether it is for trucks and buses. It can be as long as 2.5 meters. And then we also need to know how do we store and distribute this hydrogen as a fuel for transport or for heating up in industry, building, power generation, or as a feedstock in chemical industry and for many various production, right? So this is the multiple use of hydrogen in terms of application. As I told you that BIS and ARI is working on it. So BIS is framed a national standard on hydrogen, BIS 1090 and 16061. This must come up at the last page of the rule book of hCNG. And also hCNG fuel corresponding ISO TC 197 and ISO TC 22, the worldwide standard. And also the which is called BIS 16735. ARI is also participating in UN ECE and various ISO forum for development of international regulation on hydrogen. And ARI is known to fire engine with hCNG, initially with 18% hydrogen and later on with 30% hydrogen. And that gives us confidence that yes, we can work with 30% hydrogen in hCNG for BAHA 2027. So we need to slowly transit from CNG to hydrogen, and one of the best methods is to transit through hCNG. So when you want to transit from CNG to hCNG, what we have been doing from 5% to 18% and to 30%, we need to use CNG as a stepping stone to move towards hydrogen. But so hCNG is known as a transitional fuel, but the ultimate goal is to transition to pure hydrogen economy. So here you can see an example from a technical paper which talks about CNG 100% with 0% hydrogen, CNG with 10% hydrogen, CNG with 20% hydrogen, and CNG with 30% hydrogen. What happens to the calorific value? What happens to the energy? So you can see that if we use 30% hydrogen, the energy would be percentage higher. And so addition of hydrogen to CNG as a fuel in SI engine gives a significant and positive impact on efficiency, fuel economy, power, acceleration, everything, right? So hydrogen is an excellent additive to improve the combustion of hydrocarbon fuel, and it has a low ignition energy, high reactivity, dissipability, and burning velocity. Yes, this is good, that ignition energy required is low, and the reactivity, diffusivity, and burning velocity is high, but it can be also dangerous because it will be highly flammable. And the problem with hydrogen is you cannot smell hydrogen, you cannot see hydrogen, you cannot feel hydrogen. And even when hydrogen burns, you cannot see the burning of hydrogen. It's a colorless flame unless it comes in contact with a paper or a cloth or any material, and then you can see the fire. And hence, we have to be very, very careful when we use 100% hydrogen. And hence, it is advisable to use a mix of CNG and hydrogen. We'll be able to see the flame if it burns. So hCNG makes it possible to run the engine leaner, resulting in lower emission of CO2, CO, and HC at certain lambda and higher NOx emission at constant excess ratio. So we may have to use an hydrogen and NOx controlling device, maybe like an EGR or a DNOx catalyst if we use hydrogen. So a lot of work experiment has been done on a chassis dyno and an engine dyno to use this hCNG, another 20 minutes. And we, as I told you, we have to use a steel cylinder, and we have to, so hCNG cannot be, like hydrogen and CNG cannot be stored separately at the gas station and then mixed together. It has to be pre-blended. So here you can see in the lower picture that using electrolyzer, make hydrogen fuel using, get natural gas, that is methane as a CNG. CNG is stored at 200 bar, hydrogen may be stored at 400 bar. And then there is a blender. A lot of research is being done on blending, where CNG and hydrogen can be blended together, mixed together, and then transported to the daughter station where the hCNG can be sold in the market. So initially, hCNG will be available at 200 bar or maximum 250 bar. So in Baja, we are using hCNG at 200 to 250 bar. But in future, we must be able to use it at 350 bar when we use type 4 cylinder. And worldwide, we can go up to 700 bar. But in India today, PESO has given approval only up to 350 bar, right? Or to be specific, up to 250 bar. So today, whether you use CNG or hCNG, we cannot increase the pressure about 200 to 250 bar. That is the limitation. We are discussing with PESO to see if we can increase this to 350 bar, but a lot of experimentation will be required. So the initiative is taken by Indian Oil Corporation, is hCNG demonstration plant by Indian Oil Corporation at Faridabad in 2005 with hCNG at 250 bar pressure. That is what happened. And a lot of experiments are being done. So what changes we have to do, what changes we have to do in the engine, what changes we have to do, all those we will have to work on, and Greaves have been kind enough to do all this research. Then we talk about hydrogen as an infrastructure, hydrogen for storage, hydrogen is a lower density than CNG, so it requires more space for storage unless we compress hydrogen at a high pressure. So if CNG is stored at 200 or 250 bar, then hydrogen can be stored at 350 or 700 bar. Today, hydrogen can be stored in India up to 350 bar. That is what the permission is given by PESO. But in future, this may become 700 bar when we have a strong Type 4 cylinder which can withstand a burst pressure of 1400 bar. We can also cool hydrogen and use it as cryogenic storage. So there are many ways by which you can store hydrogen. It can be a compressed gas, it can be cold or a cryogenic hydrogen, or it can be even liquid hydrogen. And then it can be stored in a non-metallic cylinder. It can be stored in a metal in a hybrid complex hydride, and or it can be stored as a chemical hydrogen. So there are many ways where you can absorb and desorb the hydrogen and store. But as on today, the hydrogen cylinder, the Type 4 cylinder non-metallic, seems to be the solution. So a lot of skill development planning is done by Ministry MNRE and Automotive Skill Development Council and National Skill Development Council. They have been doing a lot of training program on this. A lot of qualification pack has been developed on this. Right? So the last 10 slides, and we are left with another 15 minutes. We have to use hCNG with caution, and our aim is to shift from 0% hydrogen in CNG to 100% hydrogen. But the event will be similar to hBAJA. So all those who have participated in mBAJA, it will be very easy to adopt and work in hBAJA. So this is our roadmap. We started in 2024 with 100% CNG and 0% hydrogen. And in 2025, we started with 5% hydrogen in CNG when Nitin Gadkari ji was there to inaugurate. In January 2026, we started with 18% hydrogen blended hCNG buggy, where the Education Minister of Bhopal was there to inaugurate. In the 4th edition of hBAJA, we hope to make it 30%. If not, then it will continue with 18% hydrogen blended or maybe 20% with Type 4 cylinder if possible. And then in the 5th edition of hBAJA, we want to shift to 50% hydrogen. And we will increase till our country is ready with hydrogen vehicles, so which may happen in 2029 or 2030, where we will be able to use 100% hydrogen in vehicles. So it can be a passenger vehicle, it can be 2- and 3-wheeler, it can be trucks and buses. And there are many companies like Ashok Leyland, Reliance, Tata Motors, and many of them are working on use of hydrogen in trucks and buses. Okay. So coming back to our hBAJA event, there is a change in engine. Earlier we were using more of cast iron engine, the cylinder block, and now we are shifted to aluminum liner. So it is a lightweight engine, lighter than BAJA 2024 and 2025. So in 2024 and 2025, we use the same engine. In 2026, Greaves helped us to give us a lighter engine with aluminum liner. And this is a bi-fuel engine where you can use gasoline, you can use CNG and hydrogen together, or you can use CNG and gasoline together. Here we are using CNG and hydrogen together. Up to 200 bar we can use, or we can go up to 250 bar. That is what we did in 2026. Now, if you want to go with 30% hydrogen in CNG with 250 bar, then we will have to shift to Type 4 cylinder. We are working on it. If we are ready, we will use 30% hydrogen in CNG. If we are not ready, by January 2026, we will continue using 18% with Type 1 cylinder. And our support from Advantex, Atul Auto, and Greaves will continue. So these are the change in specification from a cast iron based engine Greaves to an aluminum based engine. But the cubic capacity remains same. The bow and stroke remains same. It is both a BS6 engine until BS7 comes in, and it is still a port injection. It is not direct injection, and the power is also same. The torque is slightly increased from 22.5 to 23.5 Newton meter, and the size of the engine is reduced and it has become lightweight. Instead of 47 kg, it is now 43 kg. That is the difference. And my colleagues from Green, Dr. will talk more about the engine and do's and don'ts about the usage of the engine, right? So you can see the red color is the exhaust system, and then you can see the next to exhaust system is an after treatment device. So you can work on Go Green and do research on after treatment devices like catalytic converter. Okay. You also have to decide where are you going to fit the cylinder. Like you decide where you are going to fit the fuel tank. Obviously, most of the time it will be behind the firewall, behind the seat. There is a firewall, and behind the firewall will be the cylinder in a safe position, not near the exhaust system, not very near to the carburetor. So it can be just behind the firewall. It can be on the top. It can be on the bottom. So you have to do all that permutation combination and do a good design review. From safety point of view, there must not be any vehicle impact. Like if you put in the front of the vehicle, then there could be an impact, so it is dangerous. So it has to be on the rear of the vehicle or the side of the vehicle. It can be below the seat. It can be behind the firewall. It can be near the engine and so on, but away from the exhaust system. Right. So as I told you, the first hCNG in 2023 and some of the photographs for 25 and 26. And just wanted to say that in 2026, Supriya Kavade was the convener of the hBAJA event. And she has helped us a lot in not just hBAJA, but all the BAJA, and she is also the diversity face for us. She will continue to be the organizing committee member of BAJA. She is from Endurance Aurangabad, which is now called Sambhajinagar. And Mr. Saurabh Suman, who was the joint convener of hBAJA 2026, will become the convener of hBAJA 2027. And we are yet to decide the joint convener and co-convener for hBAJA, depending on the sponsorship. And hBAJA 2027 will be held in first quarter of 2027.
In our R&D. Out of that, 44 engineers are working in design center, and rest 40 are working in testing and calibration, and 20 in proto development shops and other applications. You can see to the left, there is a design center. Behind that, there is a testing center, and there is a test lab for all the instruments and validation point of view. Coming to the facilities, we had a proto shop where all engines are being assembled in a controlled environment to see there should not be any deviations during assembly of the components. Then we had a lot of support facilities like engine build, vehicle build, rectifications of the engine. Where it wants to do some certification, they ask for support, and we used to support them for that. We have upgraded it, our lab, for testing of ethanol, methanol, and now isobutanol also. Coming to the bigger dynameter, yes, from 40 HP to 1150 HP we can test here diesel engines. Of course, diesels are having blends like biodiesels and other isobutanols, everything. So that are capable of testing. Even we are exploring for bigger engine hCNG and hydrogen fuel testing in our lab. These are the same durability dynamometers. So we are having 4 durability dynamometers where we run different types of durability to assess the engine life, its performance. If any wear and tear comes, we have to improve it further. So all for this, the durability cells are being used in R&D. We also have a chassis dynamometer where we test 3-wheeler, small 4-wheeler, then 2-wheelers to assess what is the emissions we are getting on it. We are well equipped. We have a well equipped design center wherein all softwares and C design softwares are available. Almost 40 qualified engineers are working on it. You can see with the slide. You can see over the sitting arrangement. We are having well equipped facilities here. That is all located in Sambhajinagar. So this is related to our, we can say, facility point of view. Now coming to our CNG product. Okay, why our engine should be best for hCNG? I want to tell you. First of all, I thanks hBAJA to give Greaves a chance to develop our engine for hydrogen-based CNG applications. Before that, this engine was only facilitated for CNG applications. Since Vora sir suggested that we are going to explore for hCNG, then we tested, verified, optimized this engine for hBAJA application. And before that, we went through the hCNG, what is the merits and demerits of it. So if you see the merits and demerits, we have assessed it that it is very good in greenhouse gases emissions. And it is having a promising fuel property for automotive applications. Also, hydrogens has an ability to increase burning velocity of the mixture, shortening combustion duration, increasing the cylinder gas temperature, and the effective thermal efficiency increased as compared to CNG engine. Then also hCNG is having increased H/C ratio, where drastically reduce carbon-based emissions such as CO, carbon dioxide, and hydrocarbons. Its flame speed is higher as compared to CNG. So engine timing gets retarded. This results in reduction of NOx emissions. But when we tested this engine, we found that NOx emissions has an adverse effect because of hCNG. Then we have to optimize further to reduce the NOx emissions. Then we explored with different percentage of hydrogen in the CNG also. We explored with almost 5%. We started with 5%, then we started with 10%, then we tested with 18%. We are exploring for higher hydrogen percentage, but there is a limitation of supply of higher hydrogen CNG percentage because of the cylinder availability, because it calls for composite cylinders, which we have to procure it and we have to supply to the suppliers of gas who are blending this. So it is under process, and hopefully I think 2027 will be ready with 30% blend also in the CNG. Overall, if you see, it increases the efficiency and the fuel consumption of the engine, and considering to the emission point of view, hydrocarbon, CO are far less as compared to CNG. Coming to the property of it, if you can see the property comparison to hCNG to methane, methane is CNG, flame speed is much better than CNG. Then if you compare the auto ignition temperature, it is improved as compared to CNG. Then if you see the burning velocity, it is almost more than double. So these are the things which has inspired us to develop our engine and to have the assessment of a new technology and capability of an engine for the future. So we have tested rigorously, and to inform you that based on our research, we have published a international technical paper that also I'll share with you. This was thorough study was done on hCNG engine, and this engine is 395cc, where my colleague is going to explain you what is this engine specifications and everything. But considering the requirement and the upgradation of our product, we have done intensive study on our engine, considering hydrogen CNG application. And this paper was published by me and presented in SCTC conference in Italy in July 2025. So,
yeah, so let us share this paper with all the team.
Yeah.
We will share it.
So it will. Yeah, so it is self-explanatory. I request team to go through it, and I should thanks Vora sir for it. I think, sir, it is your inspiration that we have to do all these publications and everything, so that world should know how India is growing and how India is developing small engines for upgraded hCNG technologies. So this I'll share with the team. This is one of the, we can say, merit of this BAJA event, wherein we get an opportunity to explore new technologies and to learn new technologies. And I request all team members that please stay with us. I think of my team members is going to explain in detail what is this engines and how it can going to be applied on your buggy. And rest assured, Greaves will be there to support for all your complete till final day of judgment for the pricing and everything. We are there with you and holding with Baha team. Now I take over to Mr. Siraj Sheikh to explain the engine specification and its details. Siraj, are you there?
Yeah, yes, sir. Thank Dr. Kalim and Dr. Vora, for setting up this context and beautifully explain the technologies we are working on it, effect of CNG, hydrogen. Now, all the participants must have got the flavor about the technology, what we are using, and what is the future and how to work it. So I will try to just go through our presentation, main presentation of our engine. Yeah, give me a moment. I think my screen is visible.
Yes.
Not yet, not yet.
Yeah,
Okay.
actually, we can see you, but not your screen. You have to share it.
Okay.
Yeah, now
I think
it's
Now
coming.
it's coming.
Yeah,
Yeah, it
Siraj.
is coming.
Yeah, you can go to
Yes.
You can make it
presentation and
full.
use a pointer. That will be better for
Yeah.
you for explanation.
Great, great. All set. Please go ahead.
Yeah. So hi everyone, once again, good morning everyone, and we'll just start for our presentation. So this is a basic brief about the presentation, what we are going through it, engine specification, engine performance, basic engine nomenclature, sensor layout. Sensor is very important part in the engine. I will go through it. Then lubrication system, the cooling system, OMS system, the charging system, exhaust system, and most importantly, CNG system layout, gasoline system layout as well. What are the difference? And basically engine accessories and layout. It is important to understand what are the engine accessories coming along with the engine so that we can make it a proper use of it, and basically the do's and don'ts. And of course, we will cover the service schedule as well at the end. So this is basically the engine specification. As you know, it's a 400cc engine basically, and we can use in CNG as well as gasoline. It's so it's compatible to hydrogen as well. Yeah, it's a water cooled post-stroke compression ignition engine, SI engine, spark ignition engine. It's single cylinder engine. The bore stroke is 86 and 68. The power is 7.25 kilowatt, and torque is 23 Newton meter, and the weight is 46.2, and engine oil capacity is 1.4 liter. And if you include all filter, so it's 1.6 put together. The lubrication type used in the engine is forced lubrication. We have dedicated pump to supply the lubrication of the oil to all the engine parts, and we use spin-on type oil filter. And of course, cooling system is a pressurized cooling system. We have water pump dedicated to for the water coolant to the whole the engine. It's a centrifugal type water pump. We are using it. There is thermostat, and setting is also mentioned. It's very important that whenever you use your water tank to cool the engine, the location of the tank is important. We'll show you what are the location we should keep in mind while keeping the tank on the buggy. Engine oil grade, 15W50, we're using the API make engine oil. It do have electric starting system. We can start it by cranking. We use a charging system for flywheel mounted alternator. It's a FMA, wherein as engine moves, it generates the current and store in the battery. Engine low idle speed is 1200 plus minus 50 in hot condition specifically, and high idle RPM engine goes up to 4000 RPM. The tappet clearance is important parameter we have to consider for inlet and exhaust. We'll show you how to do it in practically also. And coolant we are using ethylene glycol 70-30 ratio. This is basically the power, torque, and VSFC curve of our engine, which are tested extensively. And these are the short, snap of how power it generates. You can see that more than between 6 to 8 kilowatt. Torque is almost 26 Newton meter, and we are getting good VSFC in the range of say 250 These are the overall dimensions of the engine, length, width, and height. As you know, it is important. The dimensions are important for packaging, basically. So overall height is 450, 485, and the overall the width is 330, and the 350. Sorry, width is 358, and the length is 330 mm maximum, considering the crankshaft. This is basically the parts engine which are used on it. So from top you can see that there is a HT cable, high tension cable, and injector is there, and the manifold. We do have oil mist separator here. The function we will explain later. The carburetor is always there. Carburetor is there. Spark plug is there. Ignition coil location is there. We use starter motor to crank the engine. These are the starter plate on which this starter motor is mounted. This is the flywheel mounted on the crankshaft. This is the oil pan assembly at the bottom of the engine. And these are the belt used to drive the water pump mounted on the cylinder. And this is basically crankcase, the foundation on which you need to mount using this crankcase mountings on your buggy. This is the pulsar coil sensor used here. And this is the exhaust system catcon assembly. It is mounted on the cylinder head. It's a DOC, diesel oxygen catalyst is there. And the oxygen sensor is there, top of the on the exhaust line. Yeah, dipstick is there to gauge the oil level, how much oil is inside the engine. This is the oil filling cap, and this is the rocker cover. This is the rocker cover wherein you need to open it for the tappet setting. There are the two rocker inside, inlet and exhaust. We need to set the tappet setting gap using opening this rocker cover. This is the CNG filter. You must know that there is a dedicated filter for the CNG. CNG goes to the filter first and then goes to the manifold. This is the ignition coil mounted on the block. And this is the temperature sensor. It's a basically coolant temperature sensor mounted on the cylinder barrel to sense the water temperature. And this is the oil pressure switch. This is the switch which indicates you what is the pressure inside the engine gallery. And oxygen sensor, as we explained, this is oxygen sensor which senses the oxygen inside the exhaust gases. And this is the TPS, throttle position sensor, is mounted here on the intake side. And this is a pulsar coil which sends the RPM of the engine. And this is FMA. It is cross section inside the engine. It mounts behind the flywheel. These are basically the sensors and actuators we use on our engine. This is the TMAP sensor used to mainly measure temperature and the pressure inside the intake manifold. We use oxygen sensor, as I told you, for air fuel mixture measurement. Idle control valve is there. Yeah, this valve is required to controlling the air of the engine. Ignition coil, you all know ignition coil transform the low voltage into high voltage. It is an important part of the SAEINDIA. This is the injector, CNG injector, which injects the CNG inside the intake manifold. And this is CNG filter. The working pressure of the CNG filter is a 0.5 to 4.5 bar. And the filter element which is used inside it, it's a 10 micron size. The carburetor, you all know the function of the carburetor. Whenever you are switching to the gasoline mode, it is very important. The carburetor come into picture and it supply the fuel as per your jets and requirements. This is a temperature sensor, use a coolant temperature sensor used on the cylinder head for sensing the temperature inside the engine. And this is a small ECU to control all the sensors and actuator inside the engine. This is basically a short cross-section area, just to give an idea how the oil flows from the bottom of the oil pan to the top of the rocker cover. We have oil pump. It's a zero type oil pump which suck the oil through the suction bulb, and through galleries. You can see that through all the galleries it goes to the different system. Through this galleries, first it goes to the crankshaft. It will be the crankshaft portion, and the mist, whatever mist available inside the engine, it goes through the top of the cylinder head through push rod tube, and it duplicate the whole rocker cover to the mist, and it actually the coolant outlet from the engine. From engine, it goes hot water goes to the pipeline at the top of the radiator, and it get cools due to the air flow from the radiator, and from the downside, cooled water again recirculate, goes back to the pump through this is the pump. It goes back to the engine again, and in between we have the degassing tank. The placement of this tank is very important to ensure that there should be a uniform flow in the system, and pressure should be the uniform. If that is not there, then cooling will not be proper. We have seen, so many buggies. The cooling issues comes due to the improper placement of this degassing tank. This is a specification of a radiator. You will get it this from our source. This is the layout. Just now I talk about the what are the how the water flows from the hot water comes down, goes to top to the engine radiator, then it cools down from the bottom. It again goes to the engine for the cooling, and they are shown the placement of the radiator and the engine, so that it should always get the cool air to the radiator, and the flow should not be blocked. So effective of cooling effective can be achieved if properly placed on the buggy. Same thing. Here the function of OMS. I'll just tell you how OMS works. You could see that there is the top portion of the engine. Whatever the mist oil generate here, it goes to the OMS. It's a oil mist separator, and it get condensed at the bottom, and condensed oil again goes back to the oil pan. So this cycle repeats every time when engine works. You basically blow back gases to this pipe, go to the oil separator. Oil separates the mist on the oil, and that physical oil will drain down to the engine oil pan again. This is the FMA charging system, where you can see how the FMA look like. This is the FMA part which mount inside the flywheel. This is the cross section of that flywheel, and there is one called RR unit, regulating rectifying unit. This unit function is to convert FMA AC output to regulate the DC voltage. So this is output go to the battery charging, and battery charge by this FMA. An exhaust system, you have seen that this is the catalytic converter mounted directly on the exhaust manifold, and there is O2 sensor here. Yeah, we are also using a pulley belt system. 3 PK belt tensioner system is there. This is the self-aligning belt. We'll give you the guideline how to maintain the belt tensioner in case it get loose.
Siraj Kalim here. I want to just tell about the catalytic converter. Just can you take one slide back?
Yeah.
I think this catalytic converter is a standard which is used on a three-wheeler application, but teams can decide their own designs also to accommodate on their buggy. This I want to tell. Yeah, Siraj.
Yeah, thank you. So this is the belt basically. The tension should be with the range of 212 to 269 hertz, and the end of line tension should be 154 hertz. We should not use belt below than this hertz. Now my colleague Mr. Suresh Sajjan will explain about the CNG layout and the functionality. Suresh, are you there?
Yes, Siraj, thank you. Yes, you can display the
please go ahead.
slide.
Yes. Welcome. Welcome.
Good morning,
Suresh.
everyone. Thank you, sir. Good morning, everyone.
Good morning.
This is a CNG injection layout. From cylinder to engine. This is the 3-stage reduction type. From first stage, from itself cylinder, the pressure will down, and by 2 stage, the regulator will be reduce the pressure from 10 bar to the 2 bar, which is sufficient for the to fire the engine. Siraj, next slide.
Okay.
This is the physical arrangement of the CNG layout on the three-wheeler vehicle. You can adjust this CNG layout accordingly on your buggy, and it should be the properly mounted with especially the CNG regulator and ECU and cylinder, it should be the from safe distance from the exhaust system. Next slide, please. This is a TD terminal diagram of the three-wheeler vehicle, but you can accommodate with respect to your buggy, and you can also take care of while mounting all the wiring harness should be properly routine, and it should be the away from the heat zones, and especially from exhaust system. Last time you have observed, most of buggies have got wire burning issue due to the exhaust system contacts. Please maintain the safe distance and use proper conduit tubes and routine methods for wire routing. Next slide, please. This is a gasoline fuel layout. In this fuel layout, you can see the this is a fuel tank, and fuel tank, filter, and feed pump is there. If you are mounting the fuel tank below the engine, then please use the feed pump. If you are mounting the fuel tank above the engine, means if you are arranging the for gravity feed, please don't use the feed pump, use the petrol solenoid. Otherwise, engine will run on the reach side and it will not start. And that's why we request to accordingly your fuel tank arrangements, please use the respective pump, otherwise solenoid oil. Next. This is the physical layout on vehicle, how it looks. See, if you see in the vehicle, you can see that the fuel tank is below the engine. Hence, we are using here feed pump, which feeds the carburetor, and we can run the engine on gasoline. Next slide, please. This is the engine layout on the vehicle, three-wheeler vehicle especially. You can, especially while mounting the engines, please on many of buggies, we have seen gearbox mounting, exhaust system mountings, and even vibration dampers. Use proper vibration dampers accordingly with your respect to your engine weight and all these things. Don't mount the engine rigidly on chassis, which will damage your chassis as well as engine during the endurance test. Please take care for this, especially for engine mountings. Next slide, please. This is the air filter mounting on three-wheeler vehicles. You can modify, you can customize air filter routine according to your buggies. This is example. We have shown this is for this is the three-wheeler vehicle arrangement, and you can manage accordingly your buggy. Next slide, please. These are engine accessories. We can accessories as explained by Shiraj. You can see the same. This is the component, that thermostat, OMS, crankcase hose, cylinder hose, oil filter, and cylinder head to water pump hose. These all are accessories list. If you get some damages, or if you have some issues with your component, you can procure these components from these service stations, otherwise three-wheeler outlets. Next slide, please. These are some special tools to mount to remove the flywheel, as well as to mount the belts and all these things. Please use proper tools while mounting the, if you remove the flywheel or any other, for repairing purpose, if you remove any components all, you please use the proper tools. Other, if you don't have, please consult local technicians at your end. Next slide, please.
Yeah.
This is a tightening torque list. Accordingly, please use proper torque range and specified torque while tightening the all engines, even exhaust systems and PTO covers and connecting rod, oil drain plugs, all these things. Next slide, please. And even use proper sealant also. If you open the rocker cover and PTO cover and all these things, if you please use specified Loctites for joints. Next slide, please. Next slide, sir.
Okay. It's a glimpse of the last buggy.
This is service schedule. Especially, we recommend to have a, please show the service schedule. Sure.
Yeah. I think service schedule visible now.
No.
It will come.
This is a service schedule. We recommend to have primary initial service after 500 to 1000 kilometer. If you have run the vehicle during the durability, please change the oil filter and all whatever oil filters in the after running 50 to 100 kilometers with respect to your buggies, and request to check all the air filter, oil filter, and petrol filter, tappet clearance, and all these function engine properly. You can refer this service schedule. If you have any, if you want more clarity, you can contact your convener, and they will communicate to us, and we'll accordingly we'll try to help you all the guys. Next slide, please.
Yeah, these are the basically glimpse of last participant. How they are mounted.
Yes, you can cut. Yes.
Yeah. That's it. Sorry.
Yeah, Siraj, thank you very much. I think you have presented. Now only request to the team, what our experience, things gone wrong earlier. Most of the buggies or the teams, they do last works at the last days, 4 or 5 days. My request to the team leads, please ensure that your buggy should be means ready well in advance, so that you can do some validation test, performance test on your buggy at your end. Okay. In the meantime, we recommend you can use CNG as a fuel to test on your buggy. But in case if you are stuck with CNG availability, then you can explore with gasoline fuel also for testing your buggy performances. But the most important is that you be ahead of the time, be ready before the competition start, so that whatever the teething issues are there, you can come out of it. That is my request to all team members. That was actually last 4 or 5 days will be very hectic for you. So if suppose your way comes with a complete buggy, a functionable buggy, then other activities and performance and other things you can validate there, brake test, everything you can focus much. What happens that most of the activities, braking, acceleration, you lose because your buggy is not ready. So my request is that be ready before time. It will help you for better competition. That is what our say to you. Of course, grief support will be there, and rest assured, if anything comes, it will come through the committee members to us. And if anything is needed, we are there to support. Earlier also we have supported, and in the future also we are going to support. Thank you.
Yeah. Thank you very much, all three of you, for this wonderful presentation. I think our team has understood what is this engine and what precautions they must take. The most important thing is, students, that this is just a virtual workshop for you before the actual hBAJA virtual event, which is in mid-July. What is important is that we will also do a physical workshop, preferably in Ahmedabad or Pune or Sambhajinagar, that is Aurangabad. We'll discuss with Greaves, Atul Auto and Advantex, and we'll do a physical workshop where we'll be able to show you a vehicle model also, which will help you. But what Dr. Kalimuddin says is that we must not do everything at the end like what we do during our exam. Right from beginning, so you have to, in this 15 days, you have to make the concept of your vehicle ready and also prepare for the quiz, whether it is an automotive quiz or quiz related to hydrogen and CNG. Please be 100% ready and appear for the virtual BAHA. Your concept must be very clear based on this workshop. And then once you are ready and you have appeared for the virtual BAHA, then we will do a workshop so that you can start making the prototype. Otherwise, it is almost similar to mBAHA. You can go and see some of the hBAHA buggies, which have been where our students have participated earlier. There are a lot of buggies you will find in Pune, in Kerala, in Aurangabad. So you can go and benchmark them, or you can see any mBAHA buggy. But I would prefer if you go and see the hBAHA. In case you need any help in going and seeing that vehicle. Okay, Dr. Kalimuddin, thank you very much. All three of you, thank you very much.
Yeah. Thank you.
Thank you, sir.
Over to Kashish.
Yes, sir. Thank you, sir. Thank you, Dr. Said, Mr. Sachin, and Mr. Sheikh for such an informative and insightful session. Your practical knowledge and real-world experiences have undoubtedly provided valuable learning for all our participants. On behalf of the Bahasa India family, thank you for sharing your expertise with us. Dear participants, it's time for the break now. We'll resume promptly at 2 p.m. with our afternoon technical sessions. We request all the participants to rejoin on time so that we can continue as scheduled. Thank you and enjoy your lunch break. Everyone, we'll begin shortly. Please call your teammates.
Are we ready?
Yes, sir.
We have 71 students. Shall we wait for some more time till it becomes 100?
Yes, sir, we can.
We'll wait for a couple of minutes.
Sure, sir.
Please send a reminder to your friends to join. Just call them or send, better call them and ask them to join so that we can start. Kashish, are you able
So should we start?
to see the slide?
Yes, sir. I'm able to see your screen.
Are you able to see the
Yes,
slide?
sir.
Okay. So let's start.
Yes, yes. Okay, sir, I'll begin. Good afternoon, everyone, and welcome back. I hope you all had a refreshing lunch break and are feeling re-energized for the exciting sessions ahead. Thank you for joining us once again. We truly appreciate your enthusiasm and participation throughout the event. Without further delay, let's continue our journey of learning and insightful discussions as we move on to our next session. I'll again like to call Dr. Vora, Senior Advisor by hCNG, for his session on DFME and DVP for engine and hCNG kit. So we are honored to have you once again. Over to you.
Thank you. Thank you. I'm not changing the slide. Are you able to see the change in slide?
Yes, sir, I am.
Okay, fine. So everything is working. So good afternoon, friends. I don't know after lunch whether it is energizing or whether it is sleepy, but let's go ahead and do this topic of design FMEA and DVP for engine and hCNG kit. So today, whatever I'm going to present is a general presentation on design FMEA and DVP. Design FMEA stands for Design Failure Mode and Effect Analysis, and DVP stands for Design Validation Plan. Whether you use it for mBAJA, hBAJA, eBAJA, aBAJA, whether you use it for engine or suspension, steering and brake, or for hCNG kit, everything remains the same. I'm not going to talk specifically about engine and hCNG kit, but at the end we can discuss some of the points related to that, but it's not the part of the presentation. So that is something called NPD, New Product Development. So long back, big three car companies in USA, that is Ford, General Motors, and Chrysler. They three together form, even though they were competed to each other. Like today in India, we have Tata Motors, Mahindra, and Maruti, big three manufacturer, and also Hyundai. But they don't talk to each other. They don't work together. But sometimes for a common cause, you have to work together. So this big three came together. Do anyone know what is the new name of Chrysler? You can put it in the chat box, or you can just unmute and tell me. So I said General Motors, Ford, and Chrysler. What is the new name of Chrysler? It's no more called Chrysler. It's taken over by some other. Are they able to unmute themselves?
No, sir, but they can raise their hands. I'll unmute them.
Yeah, you can raise your hand and she can unmute, or you can put it in the chat box. Kashish, if you can see the answer in chat box, let me know. I'm not seeing the chat box.
Yes, sir. Actually, chat box is also disabled. Again,
Okay. Yeah, you can just raise your hand. Otherwise, I can continue. So that you can always Google and find out the new name of Chrysler. Form a lot of things together. For example, the hardware can be commonized, or for example, the design process can be common. The design cannot be common, but the process can be common. So they created something known as NPD, New Product Development, jointly, and then all three were using that NPD process. So if you join an industry and you are there as a technical inspection, or you go to various vendors to inspect their parts, which are going to come to your company for assembly as an OEM, then you have to use all these techniques. So if you are working in a component industry, like making any component like tires, catalytic converter, suspension, steering, brake, whatever, then the OEM technical inspector will come and check with you. And you must understand what is NPD, what is PPAP, what is APQP. So quickly, I will just explain you that. So under NPD, initially make a product concept and make a conceptual design. So for example, in our case, the product concept is hBAJA buggy, right? So that is a product which you are going to design. So you have to make various designs, conceptual design. कि मेरी बहा बगी में engine पीछे रहेगा, engine का height ये रहेगा. I will put the hydrogen cylinder below the engine, between the what do you call the before the engine, below the seat, whatever you decide, between the firewall and the engine. So that is called conceptual design. So what type of suspension you will use, what type of steering will you use, what type of brakes would you use, how will you ensure that my vehicle will pass the brake test, where all four wheels have to lock simultaneously. That's a very big, difficult job. You can make a good vehicle, you can give a good presentation, you can make a good design report, but your vehicle fails in brake test, which happens to at least 20% of the team. They struggle a lot, and then we are not allowing you to participate in the endurance event. You can participate in the static event, but not endurance event. So what do you do? How do you design them? So all those concepts you have to prepare and give a presentation in virtual BAHA. So that is called product concept and conceptual design. In product concept, you fill up a form called product concept form. If you are in industry, that product concept form is filled up by a designer or a design engineer. It has to be approved by his boss, the R&D head, and also it has to be approved by the marketing head and the sales head. That means आप जो product बनाओगे वो market में बिकेगा कि नहीं, whether it will sell or not, you don't know. As a designer, you may not be aware that whatever you are designing, it will sell in the market or not, whether there is a need in the market or not. That only the marketing guy will come to know. So marketing guy has to sign off the product concept form. Then that means the design team and the marketing team both have understood what is the product you are going to design. Next comes, you have to make an outline of the design. That means you can go to make a 2D drawing, make a 3D drawing online, right? And once you make that design, then before that, you have to do a design review. So if you can see those 5 dark pink color blocks, those are called DR 1, 2, 3, 4, 5. These are design review 1, 2, 3, 4, 5. And in a design review, the design engineer will present what design he has done, what is the concept, what is the detailed design. And other members, that is, there may be member from purchase and procurement department, there may quality control, there may be member from marketing, sales, production. Everyone would come and attend that meeting, and the designer will present his design. Yes, hello? Email kiya, thank you. Okay, we'll continue. So that is what we call it as design review. At every stage, as you move ahead, it is advisable that the designer must do the design review, so that later on, once the product is ready, whether that product is a sofa, whether the product is a fridge, or whether it's a car or a two-wheeler, it is necessary that a designer must consult in the form of design review to all the ecosystem, so that later on there is no blame. अरे आपने क्या design कर दिया? ये design तो बाजार में बिकने वाला नहीं है, right? So that is what is design review. So before you do the detailed design or the outline of the design, immediately after your concept needs to be approved or reviewed, and that is what we call it as virtual BAHA. In virtual BAHA, the judges will look at your conceptual design for which you will give a presentation, and they will review it, and they will say ye barabar nahi hai, ye barabar hai, and so on. They may not, but that is what is the aim. They will evaluate, review, and give you marks. Once that DR1 is done in the virtual BAHA, then you sit down and do an outline design. You make the entire dimension. In concept, there may not be dimension, but in outline design, there will be a dimension. In detailed design, there will be also tolerances. So outline design will be just a sketch with dimension. Conceptual design will be only sketch. And detailed design will be a real 2D and 3D drawing with dimension to the scale. And it will have all tolerances, fits and tolerances, everything. And then you have to further get it reviewed, whether tolerances are correct or not, whether the fits are correct or not, what type of material are you using, what type of manufacturing process you are using. Everything must come in your detailed design. Once that detailed design is approved, then you can start making the prototype. So you start making the BAHA buggy. So now your question will be, हम तो BAHA की team में 25 लोग हैं, आप हमारा design review कौन करेगा? So the design review can be done by your faculty. Design review can be done by previous BAHA alumni who have already passed out, but you can invite them. Design review can be done by some people from industry. Like if you are in a particular region and there is a judge in those regions, there is no harm in inviting him, getting the review done, right? Like that, you must do DR2 for your detailed design. Once your detailed design is approved and everyone feels, yes, this is a good design, let us go ahead, then you start making prototype. So you make a rough prototype. You can make a full size prototype, the first prototype, and then do some trial run. And before you do the trial run, again, you have to do DR3, design review 3. And the team will give go ahead. Yes, now this vehicle is safe, it is working model, and we can do the first trial. And then the vehicle can take a big circle or can run on a straight line. And then we see whether the brake are applied or not, all those things. That is called trial run. So once the trial run is done, then you are sure that you know the entire manufacturing process. Here you are making only one vehicle, so that your work stops there. But if you're making, say, 1,000 vehicles per day, you have a target, or 200 vehicles per day, then you have to do a trial run of the manufacturing process. For example, I make a Baha buggy and put it on the conveyor, and then the tires will be assembled, the engine will be assembled, the suspension, steering, brake would be assembled. So that as the conveyor moves ahead, different parts of the vehicle will be assembled, the radiator, the intake, the exhaust, all those things. That is called initial production run or a trial run. And then once that is ready, then you can do mass production of those cars. But in your case, you stop at trial run because you are making only one vehicle. Maybe you can make a small car model as a trial run, and then, yes, tell me.
Sir, sorry to interrupt. Can you just make it in the presentation mode, sir?
Oh, I'm sorry, sir.
Thank you, sir.
Okay, yeah. So this is how the new product development is done. When you do a design, you can also do a pre-production preparation. That means when you are doing the design, parallelly you have to do the production. For example, you have designed a Baha buggy, and now you are going to make a roll cage. Then for making a roll cage, you require the pipe. If the pipe is not there, you have done the design, and when you sit down for making the prototype, we will ask, where is the pipe? Oh, we have not purchased the pipe. We are yet to purchase the pipe. It must not happen. As soon as your outline design is done and you know what type of pipe you are going to use, the primary pipe, the secondary pipe, what is the OD, what is the ID, what is the material, whether we have a material test report, and whether we have done the stress analysis and whether everything is under control. So that is called outline design, but parallelly you must get all those material. Then you must also get all those machines. For example, welding is required, whether you have a welding machine. For example, a bending machine is required, for which you can go outside and do the bending, or you can have a bending machine. There may be a shearing machine to cut the pipes and the plates and so on. So all that production preparation parallelly must be done by the time design engineer is designing detailed design, and he has already got the conceptual design and outline design approved. Then the production team, your different 4 or 5 members who are going to make the vehicle, they have to start making preparation for the raw material, for the manpower, for the electricity, for the fabrication, and for the welding and assembly. Similarly, if you're going to buy some parts, for example, you have designed a transmission, but you cannot make a gear. You are getting the gear hub done from somewhere, and then you are getting the gear housing done from somewhere, and then you are assembling the gear. Then you have to talk to that supplier. So you want to buy tire, you want to buy an engine from Greaves, you want to buy intake and exhaust system from Atul Auto. Then that preparation also you must parallelly start doing it. So design, production preparation, and getting parts from supplier must be done simultaneously. Okay, so that's about this slide. So this slide can be expanded like a big sheet, which we call it as house of quality. And in this house of quality, the green one, what you see there is VOC and the customer requirement. It starts from there. Suppose if you want to make a car in future, you want to become a startup and start manufacturing a car, maybe that car is using hydrogen as a fuel, then you have to talk to general public, you have to talk to the vendors, you have to talk to the marketing guys, you have to talk to the dealers who are indirectly your customer, and you must find out what is their voice. So you form a team who will go to different places, north, south, east, west, Some of them will talk to women, some of them will talk to men, some of them will talk to old people, some of them will talk to young people. Because your car is not just for one person, it is for an entire mass, right? Old people can also use, and young people can use, and boys and girls and ladies and gents can also use. So you have to talk to all these type of people. You can divide this. Also, you can talk to some middle class family members, from rich family member, to understand what are their requirements. What do they pursue the car which they want to buy? So that is known as voice of customer. And you can record that voice of the customer by going to various places, or you can write down those points, whatever the customer is saying, and then convert them into technical requirements. So the customer requirements, voice of customer, are then converted into the technical requirement. So suppose somebody says, मेरी गाड़ी तो एकदम प्लेन की तरह भागनी चाहिए, super fast होनी चाहिए. That means he want high acceleration. And if somebody says, सामने कोई आ गया तो मेरी गाड़ी immediately brake होनी चाहिए. That means all four wheels must brake simultaneously, must brake simultaneously, and hence it must stop immediately. It must not even go 1 feet ahead or 1 meter ahead. Then that is also the design criteria, that okay, your stopping distance is braking stopping distance is this, and this will be the brake fluid you will be using, and this will be the load, and this is how the vehicle will stop. So all those things you will have to convert the customer requirement or the voice of customer into technical requirement and make a relationship matrix. We call this as capturing the voice of customer is also called as QFD, quality function deployment. So you understand what are the qualities, what are the specifications, and based on that make a house of quality. You can also do technical benchmarking. That means you can go to, say for example, a team from Kerala and a team from Aurangabad Sambhajinagar are always winner, first, second. It's swapped between them, and a team from Bhimavaram, for example. These are the best three teams in hBAJA. You can think of visiting them, talking to them, see their vehicle, find out what are the unique design of their vehicle, note it down. That is known as technical benchmarking. Or you can read some papers or presentation which you can find out from internet and then read them. Then you have to do a product planning. You need to do a product concept and a planning. How are you going to make this vehicle? How many days it will take? And then decide the design criteria. Design criteria are those criteria which are decided based on the customer requirement. अगर customer बोलते हैं मेरी गाड़ी aeroplane की तरह दौड़नी चाहिए, so that means he want high acceleration. So what should be that acceleration? That you have to quantifiable target you have to make and put it in your design target. Design target may talk about braking distance, it may talk about weight of the roll cage, it may talk about the weight of the vehicle, it may talk about braking distance, it may talk about turning circle radius. Everything will come under design target, which are basically your design specification. There can be reliability target also. For example, my vehicle must run for 4 hours non-stop on the endurance track. So ऐसी गाड़ी नहीं बनानी है कि वो खिलौने की जैसी हो और वो 10 you run it for 10 minutes and it breaks down, the tires come out and the crankshaft fails and all those things. Then that is not the correct design. So you must also have a reliability target, and you must run at least a BAHA vehicle once it is ready. You must do validation at least for 100 kilometers, so that you are 100% sure that nothing is failing, nothing is cutting off, right? So those are reliability target. Then if there are any bottlenecks in production, in design, in execution, then you can talk about that. You can do some technical study. You can go on internet. You can find out how these parts are designed. You can read some good books and so on, right? And then based on that, you can also do function and fault tree diagram. So you need to do a wishbone diagram, which we will talk about it subsequently, and find out what are the failures which has happened up to now. Failures on the benchmark vehicle or failure on your last year vehicle. For that, you have to do a lesson learned. Lesson learned is I don't know whether it is here or not. It's not there. So lesson learned is a process where you call all the past teams who had participated in the event. So now, for example, you are participating in SAEINDIA 2027. Then call the team of SAEINDIA 2026. Some of them may be the member of your 2027 team. Some of them must have gone abroad. Some of them must have got job, or some of them must be doing further studies and so on. Invite all of them. If you invite, say, 25 of them, only 5 may turn up. but then they are like your customer and you can ask them to review your vehicle. So you can also ask them what were the failures, what went wrong and what went right. In the technical jargon, it is called TGW and TGR, things gone right, things gone wrong. For example, you will say, "Hey, bhai, mera to cylinder ही काम नहीं कर रहा था, उसमें I was not able to fill the hCNG, maybe it was choke, or somebody may say, oh, engine ही चालू नहीं हो रहा था, we were struggling and guys were not around or whatever, right? So you have to write down what were the failures, and that is known as lesson learned. What went wrong, and also you have to write down what went right. क्या क्या ठीक चला? I have designed a braking system. Did braking system work well? Yeah, if it has worked well, then I can continue with the same design, unless you want me to do some more better design. So all these things are discussed in NPD, New Product Development, and the House of Quality. And based on that, the customer requirements are converted into technical requirement, converted into design target and reliability target. On that, you can get those parts, assemble them, and make the vehicle. So the crux is, it says that at the bottom that you must do failure mode and effect analysis. So we will now look into the failure mode and effect. Before I talk to you about failure mode and effect analysis, I will tell you that you can see this yellow, orange, and blue. So yellow is a business function, orange is a design function, and blue is the process or the manufacturing function, right? All these people are separate and they don't talk to each other most of the time. Once in a year or twice in a year, they meet and then they discuss. But yellow guys are the one who are the boss, who decides कौन सी गाड़ी बनानी है, SUV बनानी है या कार बनानी है, डीजल बनानी है, गैसोलीन बनानी है, या we have to make biodiesel or ethanol compliant vehicle. All those is decided by the business team of the marketing team. Once they have freeze, yes, we have to work on this project, they will inform the project coordinator and accordingly the work will start. So whether it is business rational develop or initial service life cycle cost, or whether it is business case develop and the resources are assigned, a lot of people need to be recruited. All that thing will happen in yellow. Then comes the job of the design engineer. He will do design FMEA and process FMEA. Or FMEA, failure mode and effect analysis. And there we will be discussing what are the various components, how are they assembled, in the main vehicle. All those things step by step you will have to learn. So basically FMEA is failure mode and effect analysis, and it is a design risk assessment actually. And during design stage only FMEA plays a very important role. Then we talk about various phases where we do a business case confirmation, we take after action. So that is all done under business. In terms of design, you have to design, you have to make a small prototype, and then you have to deploy that design by making a prototype and deploy it on a customer, whether it's a two-wheeler or whether it's four-wheeler or a three-wheeler. Accordingly, you can design. So then I told you that there are two types of FMEA, process FMEA and design FMEA. So first you do design FMEA, where you take the design risk assessment. And once you feel that design FMEA is good, and there are some recommended action also at the end of the page, then you go to the production team and start working on PPAP, that is Part Performance Approval Process, or IPPAP, and so on. And for that, the vehicle manufacturer and get all those part performance approved. Then comes the last stage where all the reviews are done. We have to just review the overall picture. We have to make a good report of all the areas, and then be ready for the event. So I hope everyone has understood various phases of design and what we need to look into. Okay, fine. So first comes product. So design FMEA of product will be done first, and process FMEA of the product will be done later on. So again, same concept, verification, validation, and design also same concept, verification, and validation. So with this explanation, we go into the design FMEA. We are half one-fourth finished. I will take a break of 2 minutes and come back. Okay.
Sir, you are mute. Sir?
You are able to see me?
Yes, sir, we were able to see you but couldn't hear. Now we can hear you.
Yeah, I was in mute. Yeah, I was in mute and maybe another 2 minutes. So I'll repeat what I said. Why are we asking you to do FMEA? We are asking you to do FMEA because of 2 reasons. One is that your design is foolproof and your manufacturing process for making the BAHA vehicle is also foolproof. To make your design foolproof, you have to do design FMEA, and to make your vehicle manufacturing foolproof, you have to do process FMEA. Now, this is one reason. That means you get more marks in your static event. You get more marks because if you do process FMEA properly, your vehicle will run for 4 hours and you get more marks in dynamic and endurance event. But more than that, tomorrow, all of you will be joining industry. You may become a startup or you may join automotive and automotive component industry. Everywhere they will talk about FMEA. And FMEA is done with the help of around 5 to 10 people. So you may be one of the person in that team who may not be a design engineer, but you may be a part to review the FMEA. Then you must know what is FMEA. Otherwise, you will be sitting there like a fool. So most of the BAHA students, when they join industry and FMEA is done and they are invited, they know everything and they are able to contribute in that FMEA. They are able to comment in that FMEA, and they are also able to do the rating of FMEA. How rating is done, we'll see it in the subsequent. So please be careful and listen to this. The FMEA is something very important. When you join in industry, you know it, you will have an edge of compared to your other colleagues. So what is FMEA? Failure mode and effect analysis. It's a paper and pencil analysis method. That means paper pencil, or you take your laptop nowadays and make an Excel sheet. We will share you that Excel sheet and we'll show you that Excel sheet and fill up that Excel sheet. So that is called an analysis method used in engineering to document and explore ways that a product design might fail in real world use and find solution to reduce the risk. So there is something called RWUP, real world usage profile. So let's take an example of a 6-seater. You must have seen this 6-seater auto rickshaws which are plying outskirts of the city. So for example, if you take a Pune city, so you may not find 6-seater. Sometimes you will find 3-seater auto rickshaw. But when you go from the city to the outside limit, outside the corporation limit, you will find 6-seater where they are not taking 6, but they are taking 20 people in that vehicle. So if there are 20 people sitting in that vehicle, that means the factor of safety has to be more than 3. And hence your design must be foolproof. And the chance, if you don't take a factor of safety 3, and if you take a factor of safety of 2, then there are very high chance that your vehicle will fail. I'll give you one more example. Let's take an SUV, and the ground height is higher. If a lady has to get into an SUV, suppose a lady wants to drive the SUV, and he raises her leg and get inside the SUV, the height is very high. And maybe if she is wearing a sari or something, it becomes very difficult for her. So we put a footboard. A footboard is on both the side of the vehicle, on the left and right of the vehicle. You will find a footboard on which you can step and then get into the vehicle. So you don't have to take a big jump. You first put your feet on the footboard and then get into it. So that footboard is used only once for getting in and coming out. But in India, the footboard has a different requirement. If you go again in the outskirts of the city where vehicles are flying from village to the city and city to village, you will find people standing on the footboard. That means आपकी SUV के अंदर तो 10-15 लोग बैठे हैं, थोड़े गाड़ी के ऊपर भी बैठे हैं. That means the roof also has to be strong. और थोड़े खड़े हैं footboard के ऊपर. That means that footboard has to be designed assuming that 4 people are going to stand on that footboard, and not just that lady is going to put her feet and get into the vehicle. So your RWUP is very important. What is a RWUP? Real world usage profile. So if you're designing a Baha buggy, and my colleague Harshit Merchant is going to design a very difficult track during the dynamic event and the endurance event, your vehicle is going to jump and have a nose dive into that track, then your vehicle may fail. So that is your real world usage profile. If you see certain videos which are uploaded by Baha or by some students or some teams, you will find that what torture is happening to the vehicle and what type of torture track we are creating, not to harass you, but to ensure that you make an extraordinary design, a reliable design with a very high factor of safety, that this vehicle will run for 4 hours without any failure, right? So that is called real world usage profile. And you have to do the failure analysis. That you have to think, you have to assume that this part is going to fail. To ensure that this part does not fail, you have to find out what are the causes and consequences of this failure. And in case if it fails, what corrective action I must take. So before the actual physical failure happens, when you make a vehicle, you assume that the failure is going to happen. And if failure is going to happen, what corrective action are you going to take? For that, you have to first understand the causes and consequences, and then redo your design or modify your design, or optimize your design so that you have a rugged vehicle. So that is the aim. At the same time, the cost must not increase drastically. The weight must not increase. Suppose some part is failing, then you make the part thicker. You increase the weight or the density of the material, change the material. Then the cost must not increase and the weight must not increase. So you have to do an intelligent design. Maybe you put some ribs on the body of the vehicle so that it becomes strong and it doesn't fail. But you cannot increase the thickness of the body. Otherwise, the weight and cost will increase. So you will have to learn this art of doing FMEA, and then based on that, improving the design. So FMEA is a technique used to identify, prioritize, and eliminate potential failure from the system design or process before they reach the system design FMEA, system FMEA, design FMEA, and process FMEA. And before it goes to the customer, or in your case, before it goes to the judges, or before it goes for the endurance, you have to make your design foolproof and the physical prototype also foolproof, failure proof. It provides a discipline for documenting this analysis for future use and continuous improvement. Also, when you make a sheet of design FMEA or you put it on your laptop, when next year when the new team comes, you can give this to them and say that this is what we had done. In spite of this failed and that failed, what is required to be done is you need to relook into the design FMEA and still further make the design failure proof or foolproof, right? So there is a scope of continuous improvement and a scope for doing analysis for the future. So before doing FMEA, you have to do a lesson learned. So what is a lesson learned? A lesson learned is like a all team members. You can invite the faculty advisor. You can also invite the new team members. And we all have tea together. We all have sandwich together. You give them a small party as a motivation. And then you start discussing lesson learned. Sir, what went wrong? Why are we not in top 3? Why are we not in top 10? What part failed? And then they will tell you all those interesting story. Oh, we were there on the endurance track and suddenly there was a jerk and I found that somebody has pushed me from behind. Has collared in us and that part failed. My axle sheared off or my crankshaft sheared off or my brake stopped working, the fluid got leaked. So many, he will tell you the reason why his vehicle failed and he was not able to continue the endurance event. Or somebody may say, no, we were not allowed to participate in the endurance event at all because we failed at the brake test itself. And somebody will say, we took the truck from our college to the site, whether it was in Hyderabad or whether it was in Pithampur or Chennai. But on the way itself, the vehicle had failed because you had not anchored the Baha buggy properly inside the truck and no one had accompanied that truck. So sometimes it is extremely hot inside the truck. It is summer weather and everything is so locked in that there is no air, there is no ventilation inside. Some parts may melt. And because of the truck vibration, it is moving up the hill on various speed breakers. Your entire Baha buggy is jumping inside the truck. Unless you anchor it, like you anchor a ship, you have to anchor, or you anchor an elephant, you tie up an elephant in a zoo. Similarly, your Baha buggy is like an elephant, it's going to jump inside the truck. So you have to anchor it at minimum 4 places, right? So all 4 tires, you fix them so that the vehicle jumping reduces. In spite of that, in the center of the vehicle, it may still jump. So maybe you can put some weight on the vehicle so that it doesn't jump. Or one person must go with the truck all the time to find out कुछ failure होता है कि नहीं. When the vehicle is moving up the hill, आपका गाड़ी पीछे आ जाएगा. तो क्या होता है? What is the action? It's very, very important for you to know what is happening to the vehicle. By the time the vehicle reaches the site, a competition site, you will see उसके सब nut bolt loose हो गए हैं. You will see those torques were of no use or you didn't torque it properly. Some of the bolts have broken off, sheared off, and so on. So all this is failure, lesson learned failure. Lesson learned right from design stage, lesson learned right from manufacturing stage, lesson learned while running it for 100 kilometers on the track, lesson learned when your vehicle is moving from your college to the competition site, lesson learned during the brake test and technical inspection, how technical inspection caught you and you were not able to clear the technical inspection, how you failed in the brake test, and how you failed in the dynamic event or in the endurance event. All this lesson learned, you, since you are a new designer, you won't know, you have never participated in Baha, but your old team members have participated, they know it. That's why the designer must be one who must not be from first year, second year, he must be in third year, fourth year, who has earlier participated in Baha. So besides, and also you must say what went right, things gone right. तो बोलेगा ये डिजाइन परफेक्ट था, इसको कुछ भी नहीं हुआ, तो वी कैन कंटिन्यू विद दिस डिजाइन. इसको और भी थोड़ा वेट कम करना है, तो वी कैन डू वैल्यू इंजीनियरिंग एंड सो ऑन. सो वन इज लेसन लर्न, सेकंड इज ब्रेनस्टॉर्मिंग. यू नीड टू डू ब्रेनस्टॉर्मिंग. सब लोग बैठ के डू ब्रेनस्टॉर्मिंग के क्या करेंगे, हमारा गाड़ी कहाँ कहाँ फेल हो सकता है, ये कॉलेज का सीओपी का गाड़ी कब फेल हो गया, AISSMS का गाड़ी कैसे फेल हो गया. यू ऑल्सो लर्न फ्रॉम अदर्स and also implement that also कि इनका गाड़ी फेल हुआ तो हमारा भी हो सकता है. Or a simple thing that there was a theft at Baha, even though there are cameras and something, people are smart enough. By the time all of you go for lunch, somebody has removed one part and used it in his vehicle. So if you have written down your name on it, or you have printed your name on it, you can find out. Or you put some color code, you can find out. Or you put a camera in your store, or at least one couple of people are sitting there before everyone goes for lunch, so that theft never happens. So these are small things which are called lesson learned, which you have to learn and make yourself ready. Not only from product point of view, from the process point of view, and also from your participation point of view. Then comes the process map. That means How are you going to produce this vehicle? How are you going to make the roll cage? What are the steps in making the roll cage? First, you do the design, then you bend it, then you weld it. You will be using certain fixture. That is all you have to write down in the form of a process map or flow chart. Then you talk about the process history. How did you do it last time? Find out some procedure. So you have to start creating standard operating procedure, SOP. If you join industry, the first thing the boss will say, please study this SOP and then work on it. So SOP is a standard operating procedure, whether it is related to design, whether it is related to production, whether it is related to review, everywhere you will find SOP and you can create an SOP. If you can create an SOP that this is how the design has to be done, the next team will also use that SOP. So those are called procedures, standard operating procedure. Then knowledge, you have to read. You can buy a book of Tom Gillespie and read that, how vehicle dynamics is handled. You can read the manual of Greaves engine if they give you, or you can go through the drawing, you can go through the presentation and all that thing. So improve your knowledge in the area of automobile. Read some good books, some references, some SAE paper. Go to internet and find out. Go to YouTube and find out what people have put in there to improve your knowledge. And the experience of the people who have already participated, experience of your seniors, experience of your professors, faculty advisor, experience of your friends and your competitors also you can take it to. So these are all the inputs must be ready before you start the FMEA. Once the FMEA is done, you will get a list of action to prevent causes or defect failure modes and the history of action taken also earlier. So I hope by now everyone has understood. I was slightly slow and in detail. I will now go fast. So design FMEA is done at the concept design stage. You can do one more design FMEA, that is revisit the design FMEA once your vehicle is ready and tested and your DVP is done. So you do design FMEA, do design action, recommend action, correct all those action in your design, make a foolproof design, then make a prototype, make a vehicle, run it for 100 kilometers, and after running you will find out a lot of failures. Again, go back to design FMEA, make improvements, do action, and then find out what are the ratings, whether those ratings have improved or not, right? So that is design FMEA. Similarly, process FMEA starts once the design FMEA is done. But before you make that FMEA is done during the prototype manufacturing stage. I'll just take one call. Hello? Yes. Good afternoon. हाँ हाँ तो कल बुला लो, हम कल आते हैं. हाँ, I can also come tomorrow morning. हाँ, मनी लेकिन जल्दी करो, मॉर्निंग में करो, लेट मत करना. Done, 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 done. Yeah. Okay, fine. So let's continue. So design FMEA starts early in process. It is complete by the time the preliminary drawings are done before buying any tooling is initiated. And process FMEA, that is manufacturing FMEA, starts as soon as the basic manufacturing methods have been discussed. The design is also completed. It is completed prior to finalizing the production plan and releasing for production. Okay. So what are the steps in FMEA? First, understand how can the design system or the process and the service fail. Where will it fail? How will it fail? What is the cause of failure? What is severe? Will you do FMEA? If you can ignore it. Once you know that the will is wrong because not designed it properly. Instead of a rod of 10 mm, it has come out to be 2 mm. So 2 mm का तो कोई rod बनेगा तो टूट ही जाएगा. So you have to be very, very careful and find out what is the effect and if it is serious. And also remember there may be 3 causes for one failure. So if the material was wrong, the manufacturing process was wrong, and the design itself was wrong. there may be 3 causes of failure. So you have to write down all 3 causes, and there may be the recommended action for all 3, right? How likely is the occurrence of failure? And ये failure कितनी बार होता है? Every time I drive my vehicle, the steering wheel comes off, or every time I drive my vehicle, the one of the tire comes off, or every time I drive my vehicle, tire puncture हो जाता है. So what are these failure which are happening again and again? You must note down. For example, if you're participating in BAHA from last 10 years, it may be mBAHA, it may be hBAJA or eBAHA. It's immaterial. Same thing is happening again. The failure talking to rate of the effect, the current of the failure, how many you kilo that that means you something that is 3 cause doesn't occur again, and because of which my failure will not happen. How do I address these 3 cause of failure? And then address with the recommended action. How easy? And the third thing is how easy it is easy to detect the cause. So suppose you put a sensor. Suppose you put tire pressure sensor in your dashboard, and puncture ho gaya and you are driving on the endurance track. You don't know whether puncture hua hai. You just drive and you spoil the tire. But if you have a tire pressure measurement sensor on your dashboard, then you'll come to the pressure कम हो गया, चलो मैं next trip में जब refueling के लिए जाऊंगा तो मैं टायर में हवा भी भरवा दूंगा, right? So that is called detection. So if there is a way called onboard diagnostics, or there is a way to find out what is the failure before the failure happens, then it not how good it is to minimize the you understood the theory. System, somebody is designing roll cage, and somebody is integrating the entire vehicle, right? So the person who is integrating the entire vehicle and doing validation, for him, vehicle is one whole thing. It's like an elephant. So if you're designing only suspension, then it is the trunk, and if you're designing only steering, then it is the leg of the elephant, and so on. You'll be only concentrating to that part as for the design FMEA. But the vehicle integrator will consider the entire thing. So first start with the small one. Do design FMEA of steering, do design FMEA of brake, do design FMEA of suspension, do design FMEA of roll cage. And then all of you sit together. You can do that individually, 2 of you, but you can invite us. And then all of you can sit together and do the design FMEA of the entire vehicle. So you need to decide your boundary line. So and in that boundary line, for example, I decide design FMEA of an engine. So my boundary line is this rectangle and gray color. This is my design FMEA. But then I have to also consider what is coming in, what is going out physically in terms of energy, in terms of materials, in terms of direct or indirect cost. You have to factor all those things. For example, in an engine, you have coolant, you have lubricant, and you have an exhaust. And you have an air intake. There are 5 things, 5 fluids: air, fuel, coolant, lubricant, and exhaust. This 5, cylinder head is subjected to these 5 materials. So they are coming in, going out, coming in, going out. You have to consider that also, right? So those are called interface. The product, that is my engine, I'm doing design FMEA of engine, or I'm doing design FMEA of suspension system. And then what are the other peripheral interfaces where physically, virtually, through energy, there is some exchange of energy, right? Clear? So for example, I'm having an engine, so battery hai, gearbox hai, mounts hai, exhaust system hai, intake system hai, all those things I have to consider along with this. But anything out of that, for example, I need not consider suspension, steering, and brake when I'm doing engine, right? Okay. Then coming to the actual doing design FMEA on your laptop or on a piece of paper, it's advisable to take an A3 size piece of paper and sit down and start doing design FMEA. do some rough design FMEA, you come to some conclusion that we are in the right direction. Then you take your laptop and start entering all this thing. So design FMEA starts with all individual components of that assembly. For example, if I take, right, then that exhaust system of hCNG vehicle will consider the exhaust manifold, the exhaust pipe going inside the muffler or the silencer, and the after treatment device like a catalytic converter or a diesel particulate filter or whatever it is, depending on the fuel. So in case hCNG, it will be a catalytic converter. There won't be any diesel particulate. In diesel engine, it will be diesel particulate. So there will be a catalytic converter. And so you have to split the exhaust in different parts. So the first, now for example, here there are 3 rows. The first row will be the muffler. The second row will be a catalytic converter. And third row may be a coupling or a gasket or whatever you want. So you can write that. So, or if there is a turbocharger, you can write turbocharger, right? So you divide the system into various parts and then find out what will be the failure in muffler. The muffler will make noise suddenly and then my judges will get irritated. So there is a very less occurrence and maybe the effect is not very high because judges will just get irritated. But I'm not going to fail the exam or I'm not going to fail the review. Second is the catalytic converter. The catalytic converter fails, then you will fail in the go green event. So you will not win in the go green event, or the atmosphere will be filled up with exhaust gases which will be harmful to us. Like that, you have to find out what are the potential failure mode and what are the effects and what are the causes and consequences. Once you do that, then you have to find out what is the severity. So there are 3 numbers which you have to give out of 10. Severity you give out of 10, occurrence of failure you give out of 10, and detection of the design control you give out of 10. So 1 out of 10 or 10 out of 10, there is no 0. Similarly, second 1 out of 10 or 10 out of 10. In the third also, between 1 out of 10 and 10 out of 10. So the maximum, the multiplication of 3 is called risk priority number. Higher the number, higher is the risk. We have to address that first. So if the risk priority number is high, then it is a multiplication of severity, occurrence, and detection, which you can see in 3 thin columns. And if the severity is very high, detection is very high, occurrence is very high, then the number will be 10 into 10 into 10, 1000. And if the severity is very less, this is just a scratch has happened, nothing, the part is not going to fail, or the color has come off, it's not going to fail, then that is called less severity. 1 or 2 you give out of 10. Occurrence means it has happened only 1, it is not going to happen again and again. Whereas tire is coming out again and again, it has a high occurrence. Only once, then you may give only 2 or 3 out of 10. And if it is not happened at all, then you give 1. Correct? Then comes the detection. Detection is also after 10. If that design is foolproof and you are able to, through an OBD, you are able to find out when the failure is going to happen in advance, then the detection number is 1 or 2. But if you are not able to find out and detect, the failure itself will become a detection, then your number is 9 or 10, right? If it gives a warning of an OBD, it is 9. If it doesn't give a warning and there is no OBD, then the detection number is 10. I'll show you that sheet where all 3 are there. So then you add them together, the severity, occurrence, and detection, and add them, multiply them. So you'll get a risk priority number between 1 and 1000. And then put them in the descending order. The numbers where the high are there, you have to address them immediately. That is very, very important and urgent. And number which are less than 100, like 2 into 3 into 4 will give you some very low number. Then it is nothing urgent. You can even ignore them. So you can say, I will only work on those RPM number which are between 200 and 1000. You concentrate on that, and those which are below 200, you can ignore them. Right? Okay. Then comes the recommended action. Now we have understood that the RPM is very high. So we need to do recommended action. Change the material, increase the heat treatment, reduce the size of the bolt, increase the size of the bolt, improve, instead of 1 tech welding, do 4 tech welding, and so on. Right? So that are called recommended action. Again, effect can be 1, cost can be 3. That's why there are 3 rows in a column, in a row, you can see. So you will say effect is 1, cost is 3, and the recommended action may be even 6. So you have to write down all those actions. So you have to keep sufficient space for each of the row. And then who will work on that responsibility and when will be completed, that is target completion date. So at this, so you don't have to touch the last 5 column in virtual BAHA. I'm repeating this because many team blindly puts all the number and come. You must, in the concept design in virtual BAHA, you must not fill up the last 4 columns. You can fill up till action taken, but revisiting severity, occurrence, detection, and RPM, last 4 column is not required at this stage because you have just written down the design FMEA. You are yet to do the recommended action. So action taken is also not filled up. That is the 5th last column is not filled up. And column obviously will not be filled up until the action is taken and you come to know what has happened to the design. Clear? So don't fill up the last 5 columns. Fill up the other column for your virtual BAHA. And as I told you, we will see some example also in the subsequent slides. So these are some of the guidelines which we give. Okay, you take design FMEA of battery for eBAHA, for mBAHA or hBAHA. You take roll cage, brake, steering, suspension, all those things. So they, our organizing committee, through their various guidelines, can give you some advice. And this changes from time to time. And they may say minimum 2 items you must take in eBAHA, minimum 5 items you must take in hBAHA, and so on. Okay. So the same I'm explaining in different format. List all the function and requirement of those components and subcomponent and assembly. Then list all conceivable failure mode, whatever you heard and whatever you feel like. Then consider those effects, look for the possible cause, and then give them number in terms of severity. Then access the frequency of the occurrence and give a number in terms of occurrence. And then find out the possibility of the failure being detected, whether there is any OBD onboard diagnostics. Calculate the risk priority number by adding severity, occurrence, and detection. And then put your recommended action. And based on that, define the responsibility and time frame. And then after everything is done, reevaluate the RPM. The RPM can be reevaluated not only when we have decided what action are to be taken, after we make the vehicle and run it for 100 kilometers, only then we have to revisit the last 5 columns. Okay. The same thing in a different format. First do the function, then find out what went wrong, then what are the effects of those failure, how severe the effect was, what are the causes of that failure, how often does it work, that is occurrence, and then what can be done. Okay. So now I'll quickly show you how do you do the rating of S, O, and D. S stands for severity, O for occurrence, and D for detection. With S, so that is severity. So severity, you can see that if it is no effect, 1. If it is only fit and finish, that means the color is gone off or there is a scratch, then it is 2. And if it is making some noise, rattle, noise or something, and customer is not happy, then it is 3. And then it is noticed by most of the customer that something is wrong, it makes noise every day, then it is 4. And the vehicle is operable, but the comfort is not there. The driver is not comfortable, or the people inside the vehicle are not comfortable, then it is 5. And if the vehicle is operable, but the comfort and convenience is inoperable, then 6. And the vehicle item is operable, but at reduced level of performance, it is 7. And it is inoperable at all, the vehicle is not working condition, then it is 8. And if there is a high severity ranking with some warning of OBD, then it is 9. And there is a strict warning that this is sure to fail, but there is no warning also, then it is 10. Right? So for example, you are using ethanol in your vehicle, 20% ethanol, and pani bhar jata hai after some time, fuel tank gets, some of the ethanol gets converted into water, and then it starts rusting. So then there is a failure mode there. Then what will you do? How will you address them? Right? All those things you have to work on. Okay, fine. Similarly, we have to go to the occurrence table. How many times this occurrence happening? For example, out of 1,000 vehicles, is it 1 vehicle which is failing in that area? Then you give out of 4. And out of 1,000 vehicles, if there are 10 failures, then you give them 7. And out of 1,000 vehicles, it is more than 100 vehicles which have, then it is 10. Right? So you have to first do severity, then you have to do occurrence, and then you do the detection. How good the design is. So if you are using an onboard diagnostics, then it is 9. If you're not using an onboard diagnostic, it is 10. And other detection is like how is your design control? How many times have you checked it? Whether you've done CA analysis, whether you've done a physical test, all those will help you to find out the detection. So the once your severity rating is done, once your occurrence rating is done, once your detection rating is done, you multiply all them together, it becomes a risk priority number, RPN, right? So risk priority number is the product of severity, occurrence, and detection score. So here is one example. What is the roll cage? Roll cage, steering, brake, transmission. These are all part of design FMEA. The top portion is part of design FMEA. The bottom portion is part of processor. So let's start with design FMEA. So they say roll cage में क्या हो सकता है? Roll cage में bend, roll cage में brake. So how will that happen? That is if there is a impact load case and if there are some stress concentration. So what is the conclusion? That conclusion is that the effect was fracture and breaking. A lot of parts are getting broken. So what do we do that? So then that means if it is breaking, then CAE with factor of safety above 1.5 and proper weld joint to right? So this is how you take recommended action. So like that, you write down what is the failure, what are the causes, what are the consequences, how difficult the consequences of the effect is, and then what is severity, occurrence, and detection of those. And based on that, you finish your design FMEA, except the last 5 columns. Then you do action. Once your action is done, and you are sure you're done design verification, but you run the vehicle for some time, then you can come back and find out what happened to the action. So this is one more design FMEA where they're talking about suspension, steering, brake, and all those things. Our last 5 slides. Once your design is done and you have manufactured a prototype, what is the guarantee that it will not fail during the endurance? So you have to do some validation. So this validation of running for 10 kilometers or 100 kilometers is done. So are we building it right? So first is we have to ask ourselves, are we doing it right? What are the major costs of projects incurred in the early design stages? What is the cost of fixing a design? And what is the early involvement of CFT? CFT stands for cross-functional team. It's already 3. I have overshooted the time, so I'll go slightly faster. So you have to make a design.
Like you haven't set up any HomeKit access.
Yeah, so you have to make a design validation plan. So let's say design validation plan can be a validation plan, validation review, validation method, and validation report. So suppose you made a design and you want to now review this. You have done a design review and you understood what are the needs of the user, what is the design input, what is the design process, what is the design output, and how you convert them into a race, BAJA, buggy, or whatever. So those is called design review. After the design review is done, you have to make those parts. Before that, you can do verification by C analysis. Even before making the part, you can use some software like ANSYS, Altair, MATLAB, and do some virtual verification. Once that verification, you are very confident my designs are correct, then you make a prototype, and once you make a prototype, then subject that to a test. That is known as validation, right? And once at the end of the validation, you find out that whatever the user wants, those needs are satisfied or not, right? So that is the entire design or prototype. So then in DVP, you write down what is the output of design FMEA. So the output of design FMEA becomes the input to DVP. So design validation is the next step to design FMEA. Depending upon RPM in design FMEA, the components are arranged in DVP. So based on the design FMEA, put them in the order. It contains all the information regarding the acceptance criteria, responsible person or team, type of test, and start and finish off. Okay, so this is all what is required. Then what are the various validation methods? You can do just static, you can put it in the For example, you made a car, then put it in a four-poster, let it vibrate. So it can be static, it can be dynamic, or you must also do analysis using software and simulation. Or then inspection, how are you going to do the inspection? Are you going to do the inspection on the testing, or just look at the product, or ask some questions? And compilation of relevant scientific literature. Okay, fine. So you compile all those things and then study the historical evidence of a similar design. So you can see some examples of prediction, worst case analysis of an assembly, fault tree analysis, failure mode and effect analysis. So you can make a wishbone diagram, which we'll show you separately, and then find out what are the, we need to verify the product design with respect of following, in respect of its function, respect of its performance, respect of that is reliability, usage requirement, safety requirement, interface and compatibility validation, and maintainability requirement validation. All this are done. So how do you do a product design validation? Start in early stage validation, conduct some design review, concept design, and find out the design requirement analysis. Then build one or several production like prototype, or perform design verification testing on a process, run it for 100 kilometers and find out what went wrong, and evaluate and verify prototype performance, resolve performance concern, and build more prototype for testing, and then sign off the design. So here you can see the design requirement, that is capturing the voice of customer, design analysis, testing, and then making your knowledge base stronger. So this is another design verification specifically done for electronic items, electrical and electronic item, where you will first understand the product and come down, and then you make the product for them and go up. So it's like helping each other, and the money is properly utilized. Okay. So this is a typical DVPR template where you write down at level, vehicle level or aggregate level or part level. For example, you have a particular part, say you are doing engine. Then you write down fuel injection system. So your part becomes fuel injection system on a three-wheeler engine, on a grease engine. Then what is the performance target of that component? So whether we'll finish it in 10 minutes, or whether it is going to take 1 hour, all those things you can discuss and write it there. Then what are the performance target? Do we want very high acceleration? Do we want speed of 250 kilometers per hour? Based on that, we'll decide what is the design. So then what is the acceptance criteria? You have a target. Say, for example, my stopping distance must be 2 meters. Then your acceptance criteria is 2 meters. And the target is stopping distance. That's all. Right? Okay. Everyone has understood this table. For example, you find out the date for testing, find out the number of tests, find out what is the start test, and so on. So this is another example of design FMEA. Sorry, this is an example of a DVP. So you can see various parts being checked, and the acceptance criteria are quantifiable designs number. So it is like 65, 170, and so on. These are the actual numbers. And who will do this? What is the responsibility of that person? And whether he has sufficient resources to do the test. Okay. So the last slide, in conclusion, I will say output of compilation of failure, that is things gone wrong, is input to the lesson learned. Output of lesson learned is input to design FMEA. Output of design FMEA is input to DVP. Output of DVP is input to revised design FMEA. And output of design DFMEA is input to confidence to clear the technical inspection and win dynamic event. Right? So that's all from my side. I have one more slide to show. Just give me a minute and then we can stop. Just 1 second. Sorry to take a slightly longer time. My colleague Rajiv Vaiki was waiting for it. I need to show you one slide. Just give me a minute. It was just made. Am I audible? Let me check my Gmail.
Yes, sir.
Yeah, just 1 minute. I check my Gmail and open one slide. This is what we had mentioned in the guidelines of virtual BAHA, and hence it is necessary that I must show this to you. That's right. Yeah, this is the slide. Going to the slide. Looks like a PDF. Yeah, only one slide I have to show it to you. Okay. Are you able to see the slide?
Yes, sir. It is
Yes,
visible.
sir.
Yeah. So when you do your failure analysis, you also have to do 6W and 2H. Earlier it was 5W and 1H. That is what, when, where, who, and how. That is 5W and 1H. Now we have further improvised on it, and it is called 6W and 2H. So when used for initial problem description and mapping along a fishbone diagram. So you asked to make a fishbone diagram during virtual BAHA along with your concept based on the failure lesson learned. Then you have to draw a fishbone diagram like a bone of a fish, one straight line, and then all lines at 45 degree. Then you have to ask question that what was the failure, why the failure took place, that is what are the causes of the failure, where did the failure took place, did it happen in the dynamic event, did it happen in the endurance event, did it happen during your validation in the college, when did that failure happen, on what day, what time, was it morning, afternoon, evening, who was there to see that failure, and who is going to do the corrective action, and what area, which area will you prefer to improve the design, and how did the failure happen, and how much is the effect, or how much is the deterioration, or how much is the impact, or how much is the what do you call severity. So you have to ask this question whenever the failure happens, 6W and 2H. And if you know this answer, then it is easy for you to tackle the failure. So once 6W and 2H data is available for that particular problem or a failure, team can use a classic structural category such as 6M, that is the 6 manufacturing points. So like we have 6W and 2H, there is 6M. What are these 6M in manufacturing? Manpower. मैंने welding किया तो किसने welding किया, उसने maybe he doesn't know how to do welding. Machine, that is the welding equipment itself. Maybe you are using a wrong filler. Material, maybe you are doing a wrong welding of the material, aluminum or sheet metal का आप aluminum welding कर रहे हो, or the method of welding, or are you doing any measurement and the measurement method is wrong, or whether you are affecting the mother nature. So these are the 6H, 6M which you have to tackle. So 6W, 2H, and 6M to map out the diagonal bones of the skeleton of the fish and drill down to the root cause, followed by design FMEA. So before design FMEA, you must do this, you must do lesson learned, and during lesson learned also you can do this fishbone diagram, and then do design FMEA, and then do DV. Clear? So thank you very much. If there are no questions, then we can go ahead with the next presentation. I will stop sharing. Thank you very much. Over to Kashish.
Thank you so much, sir.
Is Rajiv Gaki sir is there?
Yes.
Yeah, he's there. He's there. Sir, can you unmute?
Yeah, just a second.
Yeah, yeah. You go ahead and introduce him.
Thank you, sir. Your session has provided invaluable insights into quality engineering, validation methodologies, and systematic product development. Now, our final technical session for today will be delivered by Mr. Rajiv Gaiki. Mr. Gaiki is a distinguished expert in alternative fuel technologies and has been actively contributing towards the advancement of clean and sustainable mobility solutions in India. With extensive experience in CNG and hydrogen technologies and active involvement with hBAJA India, he brings a wealth of practical knowledge to today's session. We will be speaking on hCNG injection kit, components, and integration. So, we are delighted to have you with us. The virtual stage is yours.
Thank you. Thank you very much.
Welcome, sir.
Yeah. Thank you, Vora sir. Thank you. I was really inspired by your deep dive session. Thank you very much, sir. Yeah. Now we can just move on. Before going to move on this presentation, I just want to know interact with all participant, not exactly virtual, but I just want to know what is meant by engine, what is meant by fuel vessel, like a pressure vessel, and what is meant by the integration between the integration. So this is a integration between the fuel vessel, like a hydrogen cylinder or hCNG cylinder. Can you just give me a brief? No, can you just give me a, some? Um, is it my voice is audible or not? Just give me a just one sec. Pick.
Yes, sir, you are audible.
Yeah, it's a clearly audible. Okay. So
Yeah, very clear,
before.
audible, visible, and also the slides are visible.
Thank you. Thank you very much, sir. Yeah, thank for the confirmation. So what is the exactly fuel injection kit? Fuel injection kit is a integral part of this hBAJA condition or any other of a vehicle condition which is related to fuel gives to the my engine from the ones from the pressure vessel to engine with the utmost proper pressure with the limit what we can say um, exactly fuel burning condition with the all atmospheric as well as running condition. So can you just move ahead with the slide? Don't worry about that. Yeah, this is a exactly architecture of a completely engine specification as well as engine fuel system. See, engine already you already get exactly knowledge of a engine system. So I'm just moving to directly the what is the exactly part of a integral part of a fuel injection system. So there is a condition between the there is a two parts. There is a sensors and actuator which is gives exactly feedback to the ECM to control your engine ignition as well as your exactly combustion which is exactly needed with respect of a lambda is equal to 1. What is meant by lambda? There is a condition of a rich and lean press. So it is a optimum position of a burning of a fuel system. So we will get uh, exactly fuel burning combustion to provide a power, maximized power to the my engine to the drive line. Next one. Next slide, please. Yeah, this is my gas cylinder. It's a exactly arbitrary of a completely fuel line system, which is a which is having a in not exactly on your buggy. Maybe it's a little bit different, but the ECM system carburation assembly with the TPS. TPS means throttle position sensor, injection, injector, injector about working under the maximum 2 bar pressure, uh, hoses, low pressure hoses and high pressure hoses with the uh, filter. Uh, in the hydrogen condition, we don't get that much low pressure filter, but we will keep with the there is a combination of a CNG and hydrogen blend. That's why so any impurity from the CNG lines should not be affect our combustion. Regulator assembly. Regulator assembly is directly come from the gas cylinder from the pressure valves and come to the reduce the pressure from 200 bar to 2 bar. And most important is the oxygen sensor and temperature sensor. He understand what is the what is the exactly term of a combustion, whether it is a lending to the richer side or leaner side. And temperature sensor sense the engine outside engine metal temperature and understand what is the exactly combustion is it very re- um, temperature sensor is always understanding what is exactly the heat of a engine outer side as well as combustion side. So it will be control the combustion whether heat is generated more than the 105 degrees centigrade, then it will be reduced directly fuel pressure as well as injection. So engine should not be get hampered. Yeah. Next one. Yeah. This is in a very first presentation. I already told you what is the sensors and what is the exactly actuators. So sensors consist of a ECM, ECU, electronic control unit, TPS throttle position sensor, TMAP temperature and pressure sensor, which is a what we can say the atmospheric pressure and temperature, which is a filled in a your manifold, engine manifold. FRPS, fuel rail temperature and pressure sensor, which is situated on low pressure sensor. Sorry, filter. ECTS is a engine coolant temperature, which is just we talked about. O2 sensor. We are not exactly using front O2 and rear O2 for this our closed loop system, which is right now BS6 version we are using front and rear O2. Next, CKP. What is exactly crank position sensor? It is a must sensor in an engine we can say that other sensors are the secondary sensors, and CKP sensor. CKP means crank position sensor is a primary sensor, which is exactly gives the criteria whether your fuel injection as well as your ignition should be go through your spark plug, and engine get combust, engine get start. Vehicle speed sensor, we are not going to use this vehicle speed sensor as well as clutch switch, because in hBAJA buggy we don't need any clutch switch as well as vehicle speed sensor. We will our for exactly hBAJA condition, our these 8 and 9 sensors are disabled. Now actuator. Actuator is a exactly things where you have to actuate the things. Means, uh, for example, you starting your vehicle, but if your ignition coil is not working in a proper direction or proper time, then your engine, your ignition engine or your vehicle will not get start. So it is a comes under the actuator. Second thing is a gas solenoid. Once you key on, your gas cylinder must on with the pressure regulator switch. There is a gas solenoid who allowed the gas to the low high pressure system to high pressure lines to low pressure line. PWM valve and CNG. So CNG injector is exactly doing the things whether the your ignition coil as well as ECM gives a feedback to the CNG injector for the to inject the correct timing, inject the correct timing for the your gas supply to the your combustion chamber. PWM valve is related to mostly the petrol carburation, where you can use your buggy for the run on a petrol in a in in availability of a hCNG or CNG or hCNG or CNG. And starter solenoid is used for the avoid the cranking, uh, avoid the more cranking to uh, did not get hampered due to the more cranking. Next. Hello. Yeah. This is a ECM information, pin number, sorry, model number A47, which is used in a current CNG market from Advantage side. And it is number of a pin is 48, and it is having all sensor active, sensor actuator, all are built in to control in and out feedbacks, everything. So it is consisting with the all calibration map related to RPM with the torque as well as ignition timing and lambda timing. Mostly the most important. And there is a the acceleration fuel cutoff is not available for hBAJA things, because there is a clutching declutching is not there. So it will be automatically run on your automatic what we can say auto mode, automatic mode. Next. Yeah, you can read it. Basic function of a ECM: control the ignition coil, spark generation, control of the injector, HPR solenoid valve, which is controlled to allow the gas flow and delivery. Air path control, lamps, gauges, which is onboard diagnosis. Low fuel lamp, engine overheating lamp is there. If you consisting same cluster which is used in a tool auto or grooves. So you will get exactly lamp marking, malfunctionings and everything. And it is operating range is 8 to 16 volt and high K line and low means can high and can low. It's a two lines which is we can easily diagnose the ECM and any kind of a troubleshooting. Next. So TMAP sensor working 5 volt, maximized 4.8 volt is a maximum voltage, which is understand pressure as well as temperature of a inside of a intake manifold, and it's around work according to map. Once your vehicle is in a idle mode, it will be show around 30 to 35 kPa. And if it is showing the 30 to 35 kPa, then it means there is no leakage from any fueling side as well as any engine side. So this will be a bookmark for any other participant. Always keep your pressure TMAP sensor mapping is should be a 30 to 35 kPa. Next. Excuse. This is the oxygen sensor, which is our completely system depend on this sensor, where the voltage between the point 1 to sorry 0 to point 0 to 1 voltage, where the in a ideal condition it should be point 42 to 45, and it should be a dangling formation, means if you see the waveform of this lambda sensor, it should be up and down wave formation should be there. And it is exactly determine the what is the oxygen from the your exhaust is coming out. According to Rich and Lin, it is functionally very best. It is already calibrated through the ECM. If it is a higher side, means my voltage is around 0.7 to 0.9 side, it shows lambda means it shows engine running on a richer side, and if it is zero point 0.1 to 0.3 voltage, it's showing engine is working around linear side. So lambda sensor should be working dangling between the 0.2 to 0.8, between the 0.2 to 0.8 voltage, and this will be a healthy formation. Second thing, coolant temperature sensor, like the engine temperature sensor. There is a two formation of engine coolant temperature sensor. One is a directly coolant temperature sensor, and another is a heat temperature sensor of a metal. But we are using a Grew's engine, so engine coolant temperature sensor working under 5 voltage, and it is gives exactly sensor to the signals and feedback to the ECM, whether the what is the exactly cylinder head assembly temperature and what is exactly the combustion temperature. Next one. These are the ignition coil, which is a dry type. Generally, for this single cylinder engine, this will be a maximus achievable, and it is help to create a spark according to your according to your CKP timing functionality, and it gives a exactly spark according to your timing. Its timing is on based on your mm, degree basis. Mostly this ignition coils we are using with the calibration in a advanced form, and low voltage is a 12 voltage and maximum is around a 32 kilovolt. Next one. This is a hCNG system. We can exactly utilize according to CNG system, because we are the blending with the hydrogen, but we are keeping same thing with the mm, OEM formation. So this is a tank, pressure inside maximum 200 bar, and cylinder wall is for the on and off condition to for the opening and closing things. The high pressure tubes, it's a completely MS tube, flexible one with the nuts and ferrule, which is gives a 200 bar pressure to the regulator of a mm, to the regulator, and it will be reduced to about 2 bar, not exactly 1.8 or 1.7. It is a little bit depend upon the vehicles and type. Second thing, after there's a low pressure hose, there is a filter, and a filter just reducing for the any oil, dirt, or anything comes from the CNG fueling or means like a petrol, like a fueling station. It's removes the all dots, oil, or any foreign particle for the through this filter to, and gives to the directly the injector, and injector working between the 1.5 to 2 bar to give the exactly combustion pressure, combustion to the combustion. Next, we don't have a LPG system layout. It is a very similar to that. Yeah. Now, SCNG layout. The CNG cylinder, which is we seen in a just a last slide. Cylinder, tank valve, filling nozzle, pressure gauge, micro switch. We are not mm, enable micro switch due to the some current condition, means hBAJA condition, but we can implement it for the safety switch as a safety switch. Next, high pressure regulator assembly consists of a CNG regulator, benzo, and other fitments. CNG filters, injector, low pressure hose, and high pressure hose. This is already uh, shown in a last slide. Next one. Please, next one. This is a bomb. Exactly. Uh, you can understand what exactly numbers, main assembly, sub assembly, and the number of a quantity is required for the hBAJA condition. Mostly the around 15 to 18 teams are already know about this. Only the new teams you have to concentrate what is exactly bomb and what exactly you have to order it. Next one. See, this is a exactly cylinder, which is a steel type one cylinder, and it is having a how to um, assemble the assembly of a wall. There is a one tool. Generally, it is a comes with the walls, totally full packed wall. If it is not there, then we can provide the tool, and you can also easily get that wall assembly tool from any CNG tank fitment uh, fitment shop or any vehicle shop. So it is not that much bigger issue right now. Everybody very well known about CNG tank walls and everything. Yeah, this is a tank wall. Exactly. Consists of so no, just go back. You can see the red one is a on and off valve. The there is a pressure switch. Sorry, pressure gauge, which is exactly showing what is exactly pressure. It is electronically as well as mechanically controlled according to pressure inside of a cylinder. And there is one switch, the uh, right side of a brass. This is a safety switch. If safety switch is open while filling of a tank, your vehicle don't get cranked in that condition. And this is a standard strictly and standard practices as per the AIS 28. The dust plug is exactly the filling valve. Whether you can fill your nozzle through the fuel pumps, CNG fuel pumps. If this micro switch is get off, then it is very difficult to remove that. It is very difficult to remove switch on your vehicle. So it should be a very careful while you filling as well as while you fitment of on a tank. Please keep in this mind some this uh, others are the do's and don'ts. It can be easily readable and understandable. To what while working pressure is line, ensure the cylinder valve shut off. If your cylinder valve is not get shut off, your filling knob is not get opened. So it is already designed as per according to safety things. But you must be understand what is the exactly things to do while you are going to be fill your tank. Similar thing I just explained. what is the exactly role of a micro switch. If a micro switch is disconnected through the ECM, your vehicle should will not start during the CNG filling, and it should be do it on your buggy also for the safety things. And always after a filling, you should use your dust plug properly inserted. Otherwise, if it is get dirt, then next time it will be a problematic while fueling, or it will be problematic for your micro switch also. Next one. Yeah, see the exactly component as well as it is based in a three-wheeler condition, but it should be same on your buggy. How the steel tube bend is there, how pressure working is there. If the pressure, see the exactly voltage between this um, pressure pressure gauge, it working with 1 to 5 voltage as well as maximum pressure will show maximum voltage shows the maximum pressure inside of a cylinder. So it is already calibrated, so you must not that much uh, uh, consider on that. If it is not working, then definitely you should get a trouble code on your cluster. Next one. This is a pressure regulator, which is uh, um, the inlet pressure will be a 200 bar, or maybe less than the 200 bar, and lowest pressure of maximum pressure is around 10 to 15 bar, and it's delivers according to your 1.2 bar to 1.8 bar, and it should be adjustable, but please do not adjust it. Please do not adjust because it is already calibrated. So don't you need not to adjust it. And this black one in top side, it should be open to the atmosphere for the reference as well as diaphragm movement. Next. This is the exactly fitment of a regulator. Maybe it will be vary with your buggy, but your fuel should be this top side should be a top side should be a open vertical to atmosphere or vertical to sky is very easy. While you are getting all these things, you will get exactly chart to how to assemble it. And already I already gave you a regulator functionality, so it will be reduced to 200 bar to 2.5 to 3. It will be reduced to 1.5 bar also, and regulate the pressure from the cylinder. While pressure cylinder is 200 bar or 150 bar, your engine get only 1.5 bar to 2.5 bar. And main thing is your solenoid valve just opening and closing for the functionality of a on and off of your gas flow. And it is a completely uh, run by ECM only while you just key on condition. You will get one tick sound to understand what is exactly whether your solenoid valve is on or off, or you can understand the vibration on this solenoid coil. Please, next one. This is a low pressure filter, consists with fuel rail pressure sensor. To understand, it is having a cartridge of to reduce this all impurities, dirt, or foreign particles to enter into the engine. And fuel rail pressure sensor is understand what is exactly pressure of the rails from the your tube lines, means low fuel lines, and it will be around 1.2 to 2.1 or 2 bar. It lies between. Next one. Most probably you will get a completely assembled line from HPR, everything. So earlier team already get exactly conditions, what exactly required, and what is the prevention, any debris and moisture, oil particles, foreign condition, everything. So it is easily provided, so it will be not easily uh, misplaced or misfitment. And particulate filter is highly 10 micron, so you will build your injector or any or your combustion will not be problematic. This is a just simple high pressure hose which is made of a MS line with nuts and ferrules, which is already shown in over there. Nuts and ferrules should be fitment properly, and this bend should be over there because if there is a vibration, that your steel tube should be take care of that. So your fitment will not be get hampered. Next one. This is the exactly condition, but it is a almost a OEM condition, but it will be a different according to your design of your buggy. Maybe sometimes cylinder will be inside of a roll cage, or sometime it will be a uh, top side of your roll cage. So according to that, you have to design your buggy, and maybe still till date, um, we are going to use steel cylinder, means typhon cylinder only. So according to that, we do the things. You should go with your design and fitment the things. Just assemble according to your design with your roll cage, how your engine is mounted, and how it will be there. Uh, The high pressure hose means steel tube line. Uh, for your buggy vehicle, it is hardly less than a 1.5 meter, less than half meter. So it is not that much mm, problematic, but only the supporting caps and nuts and fuel should be sure packed without any leakages. That is a main concern. And others are the homologation, how it is homologated, how what is exactly rules and regulation are there, how much we already uh, gone through the certification and all. This is all information. The expansion loop, which is a round one, which is we will already discuss about that. And you can use uh, soap solution, and we will recommend it depend upon the what is the exactly blend of hydrogen. We can use a swag or snoop solution also, but depend upon the what is exactly blend of a hydrogen. Last time it was a 5%. Maybe if it is a 18% up to the 18%, then we will use a swag snoop solution. Next one. This is a exactly tool, special tool, which is used for the valve fitment on a cylinder. But you will get this uh, special tool in any other market where the three-wheeler say CNG get assembled or any serviceable point, or mostly the tank certification lab where the uh, like a service things you will get that service workshop where the tank fitment certification is provided from this condition. See, this is a completely CNG information, which is you will get on any other sites, Google and Chat GPT AI tools. So it is not that much mm, any other classified things. But all teams should go through that with this presentation thoroughly. You can go through these slides with the thoroughly. You will get understand easily what exactly do, whether the pressure, whether it is leakage, how much cranking you are doing, and definitely you are not going to use immediately pressure cylinder CNG pressure. So you are just going to start your vehicle with the petrol for your validation in any other. Next one. That's all from my side. All participant, all teams should be very get prepared through the theoretically as well as practically. We'll see you very soon on other other rounds. Like right now we are in a virtual rounds. We will meet you in a physical round. and let's see what is exactly your preparations. Thank you, guys. Yes, Q&A.
Okay. So I'll ask a question, sir. We are trying to go to 30% in CNG this year. And if we use 30% of hydrogen,
Sir,
we will have to use size 4 of cylinder.
Sir, your voice is little bit breaking. Can you just repeat your question? Pardon me.
Yeah, I will switch off the camera and then speak.
Yeah.
I think now my voice is clear.
Yeah. Little bit more clear.
Right. So I'll repeat the question. This year for hBAJA 2027, we are planning to go for 30% hydrogen in CNG, for which we'll require 5-4 cylinder. So we are working on it. Yeah.
30, no, sir?
So my question, pardon, 30%.
Yeah.
So my question to you is, if we go for 30% hydrogen, and if you are going to use some steel pipes, like you said, 6-inch, 6 mm steel pipe you are going to use, will there be any impregnation problem, embrittlement problem with this steel pipe?
No. See, we will provide you a swage lock fitments with this stainless steel pipes, which is we are using in these hydrogen trains. Whether it is 100% hydrogen.
So there is nothing to worry.
No. Don't worry about that.
Even hydrogen, we can use stainless steel pipe, right?
Yeah. We can easily go with the SS tube with swage lock fitments.
Okay. So 30% you will be able to supply that to Greaves, and we will get an engine accordingly. Right?
Yeah. Easily. Even Greaves can do some calibration also, so get more and more power output as well as more fuel efficiency with this 30% hydrogen.
Okay, fine. Thank you, sir. Thank you very much.
Thank you,
Over to
sir.
Kashish. Yes.
Thank you so much, sir. Dear participants, if you have any questions, you may drop in the chat box or post on Q&A.
Participant, you can ask any question, not only related to fuel injection. Any doubt you have for today, you can ask. Tomorrow, you will have separate speaker. They will also clear your doubts.
Yes. Please ask me anything, whatever you inside your mind, any any kind of a concern or anything.
So all these part will be assembled in the engine, and you will be getting that engine. So you don't have to get directly these parts. It will be given to Greaves, and Greaves will supply this to you. Only the parts which are required for intake system, exhaust system, and the cooling system, that has to be taken from Atul Auto. So we will be giving you what is required to be purchased from Atul Auto and what is required to be purchased from Greaves. If there are no questions, then we can close the session.
Yes, sir. With that, we come to the end of day 1 of the hCNG hBAJA Workshop 2027. We sincerely thank all the distinguished speakers for sharing their invaluable knowledge and experiences. We also thank participants for their contribution throughout the day. We look forward to welcoming you all tomorrow for another exciting day filled with insightful technical sessions. Thank you, everyone.
Thank you. Bye-bye.
Thank you very much. Goodbye.
We got a question. Sandeep, sir.
Yeah, just a minute. Yes, so after the preliminary, after the virtual round, we will be sending you some NDA, which you have to sign and send back. So after the procedures, we will say you the quotation and everything. Then you can purchase the engine, you can receive, start working on that.
Thank you, guys. You may leave the meeting. We'll take the questions if required tomorrow as well.